Oh, it's just taking its time. There we go. We should be live now. Let's
Yes.
see. Is everybody? Is it live?
Yeah.
Ah, yep.
Excellent.
Yep. And of course, there's an ad. Okay, that's cool. All right. Let me. Welcome to Jupiter Direct Live. Thank you all for joining us here today to learn a whole lot about a very cool thing. So I guess we should start with introductions. So first on the list, Philip Metzchan. Would you like to introduce yourself?
Yep. My name is Philip Metchin. I've worked in film and animation for the last 20 or so years. One of the kind of starting founding members of Direct was my brother Steven. We have the same name. But my primary role in Direct was to kind of visualize some of the artwork and some of the designs that Ross and the team are coming up with to kind of get a more public face out that we could show to people that wanted to see.
All right.
Hello,
then-
my name's Steve Metchin. As Philip just introduced me, I background as mechanical engineer for 35 years now. Worked as a NASA contractor, and that's kind of how I came in the orbit of the whole ESAS, the Vision for Space Exploration, and ultimately Direct. So,
And then we have.
Ross Tierney. I was essentially the ringleader of the gang that ran Direct. I started with a post on NASAspaceflight.com's forum, and it rather snowballed from there. It very quickly was introduced to Chuck and various other people. Steve came on board. He brought his brother Philip on, and it was one heck of a ride, I have to say. You may tell from the accent, I'm a native Texan. But no, seriously, I came over to the US in 2003, actually exactly 2003 this week. So I've been here 20 years. So it's been quite a journey. And Chuck?
And hi, I'm Chuck. My beginnings with Direct were seeing Ross's posts on NSF, and I got in touch with him right away because I couldn't believe what I was seeing. It just made so much sense. I just had to be part of it. I've been a structural engineer for probably 40 years. I'm retired now, and Direct became, while I was still working, became my second life, and we lived, breathed, and ate Direct, and that's what we did. We traveled, we presented. I did a lot of the engineering behind the scenes. I wasn't so much public as the other guys. I was the guy behind the scene running the numbers.
Well, we're happy to have all of you guys here. Thank you for joining us. And then the hosts of today's show, first is Lewis.
Hello. Yeah, I'm a guy that reads about space documents online.
Aren't we
Probably
all?
a bit too much.
Well, and Lewis also did an incredibly good video about Jupiter Direct, which we're going to link somewhere, that you guys need to definitely go watch because it's really good. And then lastly, of course, you guys know, or at least I hope you guys know who I am. I'm the SLS guy on Twitter, David Willis. And with that, I think introductions are pretty good. We can begin the saga of Direct. So, where do you think we should start? I think we should start at the very beginning, which would be, Ross, did you get the subtleties? It's time to get the, Ross, you there? I think Ross is stuck. I think he might be frozen.
Yeah, he looks frozen.
He does look frozen. Okay, I guess this is gonna. Oh, power cut. Ross texted me power cut. All right, so Ross is gonna be just sitting there like that, and I guess we're just gonna have this up on stream. So I'm going to real quickly fix a little thing on the screen thing. So who can start when somebody else is? Okay, so any of you can. So now we don't have to wait for Ross to come back. So so I guess we can start at the beginning, which would be, how'd you guys start out? I think we could, Steven, there's a rocket that we could talk about a little bit before we get to direct, right?
Yeah. So let me share my screen here. So, a point I made before the Augustine Commission is that, the concept, this should look pretty familiar, but this is 1992. And then Ross was showing an earlier image of even before the shuttle first flew, but the concept of developing an inline version based upon the shuttle components is definitely not a new idea. I was a contractor at NASA for 6 years, and kind of in the maelstrom of the whole Columbia accident and kind of the soul searching that was going on. But part of the what came out of that was the vision for space exploration, which explicitly said that the return to the moon was not going to be Apollo 2.0 flags and footprints. It was going to be a sustained effort to eventually move mankind's presence to the lunar surface and then ultimately on the Mars. And one of the key concepts was to use what we had versus reinventing everything and starting over again, which we had done, after the Saturn V was decommissioned, right? Probably shouldn't have been, right? That was a great vehicle.
It was a great vehicle.
So we certainly didn't want to repeat that again with the shuttle infrastructure. So that was kind of the concept there. And remember, one of the overarching things that everybody needs to understand, this is pre-SpaceX. There was no SpaceX to speak of during this period of time that a lot of this debate was occurring, or certainly not to the extent that it is today. So anyway, that's, I would say, kind of a quick primer. A couple other images I'd just like to show. This is me and Buzz Aldrin the day after George Mueller's 90th birthday party in Seattle at Boeing Field. That should look kind of familiar.
That is that's the Direct 2.0, right?
Yeah, we're still on RS-68 engines at that point. I mean, and here's another image of that T-shirt that Ross made and handed out to us. So we got a T-shirt for our efforts. It was great.
That's what it's all about, right? The T-shirt.
Yeah. All I got was a T-shirt. So,
well, Steve, not to take us on a little, just a small little tangent, but I think that T-shirt was a part of that series of postcards and promos that we did down in Florida with the workforce when we handed out those postcards and other things to.
Oh, that's right. Yeah.
Because a lot of the workforce down around the Cape was in jeopardy of losing their jobs for a period of time, right?
Right. In 2008, in fact, Dave, you said we're going to put a lot of links down in the YouTube video, and we'll include things. Right. But one of the ones I want to include is some of the space review articles I wrote, which I think give a good backstory to kind of like pre-NSF. And I remember getting a call from the person that was helping us in the Senate in the summertime of 2008 saying, because they were trying to destroy the shuttle infrastructure, kind of like Cortez burning a ship, right?
Right.
And I said, Steve, sorry, we couldn't get into a must-pass bill in July, so it looks like it's going to be destroyed. And I remember 2008, if people don't, it was an election cycle, and so I penned that article. It went down to Florida, and it got the attention of both the campaigns at the time, McCain, the Hillary campaign, and the Obama campaign, space advisors. And the Senate drafted a letter to basically tell George Bush not to do that. Anyway, there's a huge story. There's a lot behind the scenes stuff. It was kind of anyway. So what happened is the near financial collapse of the country, plus the Russian invasion, because we were relying on Russia to get our crew to the International Space Station at that time, and so certainly that put a spur under everybody in Congress to put a must pass bill to basically protect the shuttle infrastructure and keep the shuttle flying a little longer. So, and I remember talking to the person in the Senate that was helping us, I said, I don't know what we were so worried about. All it took was a Russian invasion and near collapse of the financial system to pull this off. So anyway.
Philip, I see you've got your image up. I want to real
Yeah.
quickly point out, a lot of you have seen this image floating around Twitter, and it's the one that looks really realistic. Philip is the guy who made this image that I'm sure every one of you has seen.
This was one of the first ones I did when Steve first started talking to me about this. He's described it, and so I went back and just kind of did some 3D modeling and some Photoshop work.
It's incredible. It looks real. It really does.
I gotta say, this image was the first thing that I saw, and I was so fascinated with the quality of the image that I started digging, and that was how I found out about all of this. So, yeah, it's an important image to me in this sort of context, really.
I mean, Phil really helped polish the image of the team. That very professional. We had people at NASA helping us, of course, behind the scenes on the engineering side. But Phil really polished it up and make it like something that a larger company would actually be producing.
I don't know how many people remember this. We used to have a website.
Oh yes, the website. If you go there now, it's somebody's taken the domain, I think. But
Well, Phil, we're on that subject. It'd be nice to kind of get a new domain and at least upload this just for historical purposes. There's a ton of material on there.
Oh yeah, that might be a great idea. Make a website all about Direct with all the PDFs and stuff.
Am I still
That would be
sharing?
awesome.
No, you're not sharing, Steve. You got to share
Okay,
again.
good.
In fact, David, sorry, one last little tangent. This kind of was a family effort, at least for Steve and I, in that our brother, who's a web developer, did all the website maintenance and stuff.
Really?
Yeah,
Yeah.
Michael did all that.
The third Metzchan of Jupiter Direct.
Can I be outnumbered?
Ross, you're frozen again. Also, welcome back.
Hi.
Well, David, you want to get us back on track?
Yes, I would like to get us back on track. So I would like to talk a quick second, Stephen, about the rocket that's behind you. Just a brief, because that's a pretty interesting thing you've got right there that you also did right before Direct, right?
Oh yeah, that was the Jupiter. So the numbers were based on stages of orbit. So Jupiter 1 was a single stage orbit, and that's another concept too that people need to understand about our overall plan. There was no commercial crew to the station, so the concept is that while we were transitioning away from the shuttle, we still needed to support the International Space Station. So we needed a variant of the vehicle that could do that, basically deliver crew and payload to the station, and that took a smaller rocket, the Jupiter 1. Jupiter 2, with the full upper stage, was intended to be more the lunar or the outward bound, beyond Earth orbit focus. And maybe people are familiar or not with the Shuttle C, basically where you replace the space shuttle with a cargo container. And I was thinking, well, shoot, you can only put so much mass slung off the side of that tank before it becomes a problem. I said, well, shoot, if I had another tank on the other side, we could solve that problem. Frankly, it looks better nose on than from the side, but it was truly shuttle derived in the truest sense of the word. Because the tanks were reused. The tanks were identical.
Except for the Saturn V first stage, I think.
That's another good thing. A lot of people think that the center core there is just a Saturn V. Can you explain what that actually was?
I forget who did the video of the Jupiter 3 launch. It was excellent, by the way.
Hazy gray art.
Yeah. So
somebody says in chat that it looks like something from Kerbal Space Program.
Yeah. But again,
I call it the Franken rocket.
The Franken rocket.
And just so you guys know, we are checking the chat. So if you've got any good questions, I'll forward them.
But those are attempts to look at different configurations, different.
Oh, I like that one. That's one I haven't seen before. I might have to ask for that after the stream because that's a really cool image. I'm a big fan of the white external tank. I know it's it's a lot of weight, but it's cool.
It's only 600 pounds.
It's only 600 pounds. Like, who cares, right?
The Jupiter 3's got like 400. It's like 4,000 even.
Yeah.
Yeah.
So what's 600 pounds to that rocket, right? David Porter says, "Hi, Ross."
Oh, hi there. Cousin from England.
So Steve and I, we did. What year was that we started doing shuttle Jupiter 3 stuff? Was that the?
Gosh,
2004.
Yeah, 2004. Again, if you read the vision for space exploration, it was, we want to use the existing infrastructure. So it's like, well, shoot, if I can just use the tanks as is, right? And then I have to build this center thing. And remember, you want to be cross-compatible with the existing space shuttle, because the concept is this vehicle would be being built and tested while the space shuttle was still in operations. So it's one of those classic problems where you don't have the funding unless you shut down the other program. The description was given to me is you're reaching into a jar to grab a stone, but you can't pull the stone out without releasing your fist, right? So you're trapped.
Right.
You can't. And that was one of the concepts in the VSC was that, look, you guys aren't going to get any more money. We just want you to direct it gradually towards the lunar mission and still finish the space station. So, again, there was no commercial crew. There was no SpaceX. All we had is what we had. So it seemed like a logical conclusion. I think if I was to kind of characterize how the project kind of went a little, and these in the early days, and we'll get into the NSF side here shortly, but Ares 1 was a requirement. And of course, it was a forced requirement, for lack of a better word. And that kind of dovetailed into everything, right? Because Ares 1 was limited in capability. It made the second launch system be incredibly large. So much so that it stopped being shuttle derived. And even frankly compatible with Kennedy Space Flight Center. So, I think that's what Ross and I both came to a conclusion to, and that's kind of how we connected up. But we both had the same idea, and it just wasn't us. There's a lot of people within NASA that had the same concerns, viewpoint. But it's awful hard to keep your job if you're going to be, adamant against the program of record, what it became known as.
That actually segues us pretty goodly into something else I'd like to talk about. But first, we've got a question from the chat for you, Stephen. How big is the fairing on that rocket?
Well, the tank was 10 meters, so usually you can go a meter out each side, so 12 meters.
A 12-meter fairing. Goodness gracious.
And that's the thing, I mentioned that before the Augustine Commission. You can talk about lift capacity all day long, but the average density of a mission beyond Earth orbit is typically that of balsa wood. So you've got to increase the volume. Unless if you're doing propellant resupply, then sure, go ahead. You can have relatively small fairings. I mean, liquid oxygen is very dense. It's like water. But when you start talking about spacecraft, they are incredibly light. And so you have to expand the volume at the same time as lift capacity. And that's one of the nice things. So
that was your famous quote about launching a bag of hammers.
Yeah, a sack of hammers.
A sack of hammers. If you're just launching a sack of hammers, you're not volume constrained.
Correct. And the good news is most, and this is where Paul Smoudis, who's one of our early supporters too, lunar scientist, said, look, if you want to get space to be less expensive, we got to stop throwing away our spacecraft. And to do that, we need to start resupplying them with propellant, and also ideally develop that propellant in situ where you're at, right? So the moon or Mars. And there's a lot of aspects that are in the direct plan that a lot of people don't talk about, but they should. One is the use of propellant depots, which came from Paul Smoudis, and then Dr. Farquhar is another early supporter of direct, or our approach, or our initiative, if you will, to instead of stage in Earth orbit, which is what Ares 1, Ares 5 was doing, to stage in a halo orbit around the moon. In fact, he tried to get that as part of Apollo 17 as a young engineer and got shot down pretty rapidly because he said, the bosses said, look, the mission of Apollo 17 is to return everybody back alive, not to do some crazy halo orbit where it can access different parts of the lunar surface. So So, and I just mentioned their two names because unfortunately they're deceased now, but we had a ton of talent that just helped us along the way.
So
This wasn't, we were the tip of the spear, for lack of a better, we were the public tip of the spear, let's put it that way.
So then that actually, I think that segues quite nicely into how did you find these people? How'd you all come together to do this?
Well,
That
Ross
was
is-
probably me.
Yeah, Ross was definitely the ringleader.
In 2006, I was getting active on.
And there goes Ross again. Well, while Ross is returning, we've got a question for the Direct devs from somebody called Saturn Shuttle. For the Direct devs, I'm curious. I've heard conflicting opinions. Is SLS Direct?
It's in the Augustine paper that's on public and downloadable. We have the configuration that is SLS on one of the configurations.
Why do we have two Rosses that are doing two different things? Hold on. That was really weird. Sorry to interrupt you, Stephen.
Because one Ross isn't enough.
I think my main machine's back up and running now.
Oh, good.
To answer the question kind of directly, though, I mean, the Jupiter 246 stretch heavy configuration is essentially SLS with a slight, and we did do a version, as in some of the artwork, with the Delta 4 upper stage.
But I think I want to make a distinction here too, is that it's just a concept. Without the 50,000 plus people at NASA and their contractors, it would never have flown. I mean, an idea just is an idea until you get a good team behind it.
So
Okay, I apologize. I've had some technical issues here. To quote Apollo 13, I think we just had this glitch, had a glitch for this mission.
oh boy, do we need to get the red team out to?
There's a quote.
Do we need to get the red team to fix some Ethernet issues?
I think I'm back up and running now, so I can actually, the archive of documents and stuff is now available again.
Yay!
I apologize for all the problems there, but yeah, hopefully that's
So
now
Ross, the time you're at, I kind of brought him up to NSF, so it's kind of your time to take over, I think.
fantastic. Okay, so 2006, I've been a little bit active on NSF, just getting my feet wet. The ESAS report had come out recently, which was essentially in response to the Columbia accident. Everybody had decided shuttle wasn't such a good idea after all. Let's finish the International Space Station and plan to do something to follow it that's a lot safer for crews and hopefully gets us beyond low Earth orbit. The result, as we saw, was out of Mike Griffin's office at the time, who was the NASA administrator, came the ESAS report. The first copies were distributed on NASA Watch, which were immediately pulled because they had too much information in them, and another copy went in, which had less information in it. And that was sort of prescient for what was going to be the pattern of dealing with NASA for the next 6 years. Getting information proved to be a problem at every step along the way. I have to be honest about that. All right, I was away. Can I just check? Did we actually get everybody up on the same page at the beginning of this?
I
Kind
think.
of lay the framework as to the time scale.
Did we do that? I think we established who you guys are. If you guys, Ross, if you want to reiterate that, I think that might be useful.
Okay, well, this is early days in the Griffin administration at NASA. Putting it into perspective, it was around about the time of the very first Falcon 1 launch that did not make it to orbit, that took off from Omelek Island and plonked straight back down again into the island about 30 seconds later. So that kind of puts you in a rough position as to where we were in the timeline. ESAS had come out and everybody was looking at the ESAS report, and there were a variety of vehicles described in there. And the choice that the report had actually made was to build a single vehicle based around a single solid rocket booster with an upper stage on the top and a capsule to carry 4 people. Then they were going to build a much larger vehicle, very similar to SLS, in fact, as a second vehicle. And it became very, very clear to everybody who was reading the ESAS report in detail, hang on a second, how are we going to afford 2 new vehicles? I believe, if I remember correctly out of ESAS, and I'm trawling my memory nearly 20 years back at this point, it was something in the order of 16 billion for the Ares 1, what would become the Ares 1, the CALV, the crew launch vehicle, sorry, the crew launch vehicle, the CLV. And then another, I believe, 25 billion for the CALV, the very large heavy lifter that had to go with it.
That's the
And everybody's scratching their heads looking at it and thinking, how are we going to afford $40+ billion for 2 new rockets?
Plus the
And
spacecraft,
the assumption,
right?
sorry?
Plus Orion and Altair.
Yeah, absolutely. Orion was going to be multiple billions on top of that. And let's not forget the lunar lander, which is probably the most expensive element of the entire operation.
So that was going to be be 2 new spacecraft and 2 new rockets, and we were somehow going to have to afford that.
Yeah, it looked ambitious, and it was clear very early on that Mike Griffin's administration expected Congress to cough up more money.
Did they?
In the first attempt to do so, he was basically asking for something in the order of 3 to 4 billion extra a year for NASA. And if I remember correctly, NASA approved something like 1.5. And that was when a lot of people started to realize, wait a minute, we're never going to be able to afford this.
Not only that, one of the debates, Ross, was that the Ares 1 wasn't really increasing capability beyond what we already had in the ELV fleet.
Now, Ares 1 had actually come out of a Planetary Society paper that had been written in 2004 by Mike Griffin before he became administrator, and Scott Horowitz, who was at the time working in the sales department at ATK, the solid rocket booster manufacturers. And they had come up with this stick rocket, is what they called it, effectively.
The stick rocket.
Say again?
Oh, I just reiterated. It's the stick rocket.
Yeah, the stick rocket. It was this solid rocket booster stick with an upper stage, and it was this. I think the paper said it was estimated to lift about 18 tons to low Earth orbit, and there were a lot of other vehicles out there that could do that. But it was Scott Horowitz's job to promote products for ATK, and he got together with Mike Griffin, wrote the paper, and that set the timeline for everything Mike Griffin would do from that point forwards in the program. He became administrator, committed to the report, and the report was written by Doug Stanley. And it's quite interesting. Doug Stanley actually did a draft that said, let's do 1 vehicle based on 2 solid rocket boosters, modify the external tank in the middle to be an inline configuration with the engines on the bottom and a payload fairing on the top, and a crew vehicle on the top of that, and fly 2 of them to the moon. And the draft of that report actually exists. I've seen a copy of it. That went to Mike Griffin's desk. It was rejected by Mike Griffin, who told Doug Stanley at that point, rewrite it. I want the bigger heavy lift vehicle and the stick, which was, in the ESAS report at the time, LV 13.1 was the stick, and LV 27.3. I can pull these up in a second if anybody's interested. So those were the 2 vehicles that ultimately got selected by the ESAS report. It's interesting what was happening behind the scenes, though. This all dated back to Scott Horowitz, Associate Administrator for Exploration Systems Mission Directorate, if I'm not mistaken, had been working on these concepts before he ever joined NASA again, or rejoined NASA. He'd been an astronaut formerly. So that was where ESAS came out. That's where the costs really set themselves. And it was pretty clear that those 2 vehicles were never going to be fully paid for by Congress, and we were going to get ourselves into trouble. So there was a lot of speculation on NASA spaceflight, a lot of people just going, oh, what about this idea? What about that idea, et cetera, et cetera. And I joined in. But I did a couple of key images. And it was an interesting post that went up there, and it showed the progression of the Ares 1 to the Ares 5 from shuttle. And then I put in our concept, and our concept was much closer to shuttle derived. And that was when we started to get responses.
Can you do you have a picture of this that you might be able to show us?
Yes. After my reboot, I'm having to find everything again. So bear with me a second here. I'm not as prepared as I was before the reboot.
Ross, while you're talking about that, is a great segue into kind of the engineers within NASA at that time, which I was one of them. Kind of our, it was really frustrating. Basically, to your point, anything that didn't include the Ares 1 was dead on arrival, no matter how good of an idea it was.
Yeah, unfortunately.
And from an engineer's perspective, especially given how important this program was to getting us back to the moon, and we had the same concerns you talked about, that it was never going to happen. And all that was going to happen is we're going to lose the shuttle, the infrastructure, and everything else, and be stuck with a vehicle that, the Ares 1, that had no more capability than something we already owned, or was already flying in the ELV fleet and so on. So the Atlas and Delta programs were perfectly capable of duplicating what Ares 1 was doing.
Yes.
With modifications, of course. I mean, the trajectory for escape, health management system, so they know when to punch out and so on. But, yeah. You got the file yet?
I do.
Ooh.
I do. Okay, so we started out with this was the arrangement. This was in one of my original posts that really sparked the interest. And as you can see, the solid rocket booster is considerably taller than the ones used on the shuttle, being a 5-segment instead of a 4. So they were dissimilar. The tanking was completely different, and the engines were completely different. There was also very little similarity progressing up to what at the time was the Ares 5, because this was powered by RS-68 and was a 10-meter diameter core.
It's a big core.
Big core. Going back to Apollo-sized rockets again. And that was the reason. I believe it was a nod to Apollo.
Ross, what was the upper stage engine on the stick?
Initially, it was supposed to be an SSME, but they found very quickly that the ground support equipment needed to restart, or to start an SSME in the air. To fit that onto the rocket was essentially impossible. And so they went and had a look around at other alternatives and decided a modernization version of the J2S that had been developed for the later Apollo missions was probably the way to go, and that became the J2X.
And also, Steve,
that ultimately reduced the performance of the upper stage, and so they had to go to the 5-segment booster to compensate.
Well, and also, wasn't there also an issue flying out there about Pogo with the SRB because it has that resonance?
Oh, yeah,
that occurs.
Very much so.
Yeah. It's one of those kind of things that looks great on a bar napkin, that as you get into it, it's like, okay, this is, and there's a lot of concepts like that where initially it seems like they're great ideas, but when you get into them, it's like, oh. And I think that's organizationally, and that's one of the things I like about SpaceX in general. Organizationally, there's nothing wrong with making mistakes. The problem is not learning from them and correcting in time and throwing good money after bad. Right?
Yeah.
So this was where we had a look at what we were thinking about. And I put these two images, the Ares 1, Ares 5 image, and this vehicle, which we called Ares 2 at the time, would later become Jupiter. And you can see there's a lot more commonality.
Real quick, I've got a slightly tangential question.
Sure.
You've got it here, like you just said, it's named Ares 2, but went to Jupiter. Why Jupiter?
That was actually a name that Steve had invented for his
my brother
line of development.
my brother Philip was the one that came up with Jupiter because they're thinking, well, what's after Saturn? Well,
Yeah, what's after Saturn?
Well, one of the reasons I ask is because I'm sure you know that there was a Jupiter rocket already.
Yeah.
The Jupiter C.
The Jupiter C. So
I think, David,
We actually had a few people come to us from the Jupiter C program and actually say, hang on a minute, you're stealing our name. So, yeah, we had to do a bit of a nod to that, but yeah, we understood what they were saying.
David, I think to your question, though, you'll see Ares 2, Ares 3, Ares 4 on a lot of the diagrams. There was a decision to kind of, I don't know how to say it, to play nice, get in the fold of the naming convention that NASA was using and not, constantly, because we were for NASA, like we wanted to help.
So the naming direct is sort of like, see, we're not getting rid of Ares, we're just doing a different Ares rocket.
Right.
Yeah.
Indeed. So this was where it started. And within 24 hours of that post going up on NASA Spaceflight, I had been contacted by about 8 people, including Chuck was in the first round of these. And they were basically saying, that's much more sensible. And the guys who were working for NASA at the time were saying, that's much more sensible, but I can't say so publicly or I risk my job.
Oh. So you said...
At which point I said, well, I'm not being paid by NASA.
I'll say it.
I'm happy to say it. You just tell me what you want me to say.
Real quick, you said...
that was where it really started.
You said that one of the first people to see this was Chuck, right? So I'm wondering if Chuck might be able to give us his initial thoughts on this. Also, you might be muted, Chuck. You might have to unmute.
Yeah, basically Ross was getting ready to put together a paper to actually present it, and my initial thought with him was to help him edit that paper because he was really in the weeds of putting the concept together. So that was my initial contact with Ross was to edit the papers that he was doing. I had my engineering point of view and the manufacturing point of view, and between the two of us, between Ross's thoughts, I helped him put the nuts and bolts together.
Oh, we have another question.
Chuck was actually central. I just want to make the point. Chuck was actually my right-hand man throughout this entire process. I think we talked every single day, at least once, for 6 straight years.
Oh,
wow. Between us, we were probably putting in 40 or 50 hours a day on this project, on top of our day jobs.
That's incredible.
Yeah.
I mean, we were putting in an enormous amount of time on this, and Steve had his day job and Philip had his, and so they weren't able to put quite as much time in, but they contributed in ways that the rest of the team just could not do, and that was wonderful as well. And we became the front of the house. We became the people who were known, and we were able to protect the identities of the people behind. Now, I have to say, early on in the program, unfortunately, 2 of the people who were involved in the program did actually make their presence known to their own internal teams. And both of them lost their jobs.
Oh, man. That's
And at that point, I became utterly retentive about protecting names. To the point that after the SLS launch, I kept the list of everybody who was involved and all the contact details. I kept the list until after that SLS launch happened, and we tried to have the get together. And once we had the get together, I actually have now deleted that list. I do not have that list any longer. I know off the top of my head maybe a dozen people how to contact them straight away, but the rest, their identities are gone forever now, unless they come forward for themselves, which they're totally free to do.
Well, that's pretty incredible. I have to say, the fact that NASA was interested in firing people just for you saying, "Hey, I'm part of Direct," that's a bit.
Yeah, it was an unfortunate situation. They some people within the organization didn't like the fact that it was being questioned. And that wasn't just within NASA as well. That was in the public domain as well. We caught a lot of flack. I'll say absolutely, passionately, every single person, we had 110 people involved in Direct by the end. Every single one of them, hand on heart, loves NASA and the program. I'll categorically say that. We don't necessarily agree with all of it. There are places where we think it's got weaknesses and problems, and we were trying to fix those to make the agency work better. That's where all of our motivation came from.
Ross,
Some people took that the wrong way.
I would like to add to that. After the 2010 Authorization Act that was clearly aligned to that, I think NASA's done an amazing job in Artemis.
Yeah, I agree.
They have a great balance between proven systems along with taking risks on things that have great payoff. So I don't know. I think what came out of this whole kind of debate and conflict, it was a way better program.
I agree.
And one that definitely shows signs of being incredibly successful.
If there's one regret that I have over the whole Direct effort, it's that we were never able to repair those early bridge problems to the agency. A gap created between them and us. And I think that's how NASA saw it, NASA management saw it as well. And I wish we had known more about what we were doing, because honestly, we were making it up as we were going along. I don't think anybody in the group had ever run a campaign like this before. So we were finding our feet as we went, building the plane as we fly it. It was actually really difficult.
What was the first inroads with Congress that you guys had? What was the first?
That was Steve. Steve.
The first time you went, who was it that you spoke with, and how was that set up?
Well, I'll tell you a funny story on that. Because Buzz Aldrin approached me at one of the conferences I was at in DC, first time I ever saw him. And once he's kind of in your orbit, you're in everybody's orbit. And we talked to Mollahan. He was the head of the appropriations for NASA. And we want to get a meeting with him. And his staff said, well, if we bring Buzz Aldrin along with you, I think we can pull that off. So we go do the spiel, and this is a better, everything that Ross is talking about. And of course, they don't want to spend money like they didn't have it. Let's just put it that way. They didn't have the money for Ares 1, Ares 5, so they're looking for a solution that would fit the budget and still achieve great things. And to find out that the only reason I got that meeting is because he wanted Buzz Aldrin to sign his wooden space shuttle. He had a wooden space shuttle, and he was missing Buzz Aldrin's signature on there apparently. So. Yeah.
Isn't this you guys at one of the meetings?
Indeed.
Oh, is that Chuck? Is that one of the models that's behind you right now?
Yeah.
Oh wow.
Actually, hang on a second. No, those are the two that we left at NASA.
Right. Those went into the library at NASA.
Because it was windy and rainy outside, and we didn't want to carry a paper rocket around outside in DC. So.
Okay, that makes sense.
And I believe they're still at the library in the E Street headquarters.
E Street, you said?
E Street, yes, DC.
Ah, gotcha.
So, Steve, when you had those...
they're history now. They're part of the NASA history.
Steve, so when you had those meetings, did you have your AIAA decks, or what did you guys bring?
So the 2007 paper, which I think still is the record holder of 130 some odd pages. And by the way, it goes into way more than just the rocket. Again, the things that are, I think, underappreciated from our plan that's in Artemis now is both the staging position at the halo orbit around the moon and also the propellant depots. Those are all key foundational elements of the Artemis program.
Lewis touches on this in his video a year ago as well.
Good.
I think he actually read the whole 133-page paper. He's the person who read it.
And in fact, Ross, there's an image for the for the Mars lander that looks a lot like Starship.
Yeah.
So
Yeah, there's
more
some
Starship.
echoes of Starship back in the past from this kind of time.
Well,
Methane
and
engines and stuff.
it's interesting. When I was giving the Augustine Commission presentation, Elon was probably only like 20 feet away from me. And when I was talking about Werner von Braun's connect mode, where you assemble the spacecraft in orbit versus transfer or propellant mode, or what do you call it? I think it's transfer mode. But anyway, I could see he was definitely interested. Let's put it that way.
This is the AIAA deck, right, Steve?
Yeah, I'm sure it is.
Yeah, this is the presentation that was made.
Yeah, just tell me to stop if there's any interesting.
Yeah, I mean, this is all, the paper goes into
Just skip through it while we talk.
Yeah.
Paper goes in, and we should again have links to all these in the video or the YouTube.
I think that's a good idea, Philip. After this stream, if you want to maybe put take this and put this file I don't know if you can do that with a Google Drive, but if we put this
hold on a second, Philip.
Link.
Yeah.
I want to make a point. Actually, this was actually one of the important bits of the whole direct architecture, the mentality behind it. It was a very holistic approach. It was, what do we have today? Now, this is 2000. I don't know.
Yeah.
This particular paper was
2007.
But yeah, from the inset in 2006, this was baked
Right.
in. It was the shuttle MLPs are there. The work service towers inside the VAB are already there, ready to handle a shuttle-sized piece of equipment.
Right.
We're going to need a tower. So what do we need to do to the one that's out at the pads at the time? All right. And we went into a lot of detail to figure out what is the lowest cost and quickest way to close the gap at the end of the shuttle program.
Not only that, the concept is we would be in the testing while the shuttle was still operating.
Exactly.
Because
And
our
that was
goal
one
is
of the
to
real
not have a
key
gap.
parts of it. Yeah, that was absolutely part of it. It was we wanted to figure out what's the quickest way to transition from one to the other. Yeah, here are the work platforms inside the VAB. And we show how many of the work platforms had to be completely demolished and replaced for the Ares system.
That would have been most of them, right? Because the rockets are
All of them.
completely different sizes.
Every single one had to be.
To Steve's point, one of the images, I don't know if you have it, Ross, showed a shuttle actually taking off with the Jupiter rocket sitting on a pad ready to go
Philip
next.
did some amazing artwork. I think it is in here somewhere.
Oh, real quick, Philip. Actually, I'll let that go first. But then I got another question because I just saw it and I remember somebody asked a question about this. So answer that one first. Show that picture, and then I've got another one for you.
Philip, I will say, is probably the most talented digital artist I've ever come across, and that's saying something. I used to work at IDOS that did the Tomb Raider computer games, and there were some really talented people there, but Philip is in a league of his own as far as I'm concerned.
Yeah.
Oh man, that's an incredible picture. Goodness gracious! That is
Just before we move on,
impressive.
I want to make a clarifying point about the size of the tanks. And I don't think people who aren't in the circle for rocket engineering understand that changing the diameter of a rocket stage breaks everything. It breaks your cranes, your transport, your mounting, your work platforms. Everything has to be redone, which is why Ares 5 going up to 10 meters meant they basically had to rebuild everything because the shuttle SRB vents were in a different place. The engines were in a different place. The work platforms all had to be completely rebuilt, different heights. The cranes had to be rebalanced and resized. How are you going to get it into the VAB? Because it's not manufactured there, it's transported there.
Lewis,
with
to your
Direct
point,
keeping the 8.4 meters and SLS keeping the 8.4 meters was so important because you didn't have to redo all of those things.
One caveat
to your
with that.
point, SpaceX, Elon actually said the very same thing. He said the rocket was relatively easy compared to stage 0, which is all the stuff that goes into lighting these things up. So,
But Lewis, there was a flaw in the plan, unfortunately. Although SLS shares the same 8.4 meter diameter as the shuttle external tank, NASA had spent something like 4 years planning for the 10 meter tank on the Ares 5 because it was using the RS-68 engines. All right. And so they actually got rid of all the tooling, all that support equipment, everything in the VAB that supported the 8.4 meter rocket configuration was all scrapped.
That's interesting.
And then
that
they changed
answers a
back to the
question I had.
8.4 meter.
Yeah, because that answers the question I had. Is the
Philip, hold on to
a lot
that
of the
picture.
point-
I'm going to ask you a question about it. Sorry.
Yep.
a lot of the point of keeping Direct's sort of maintaining the diameter was that you wouldn't have to redo all the assembly path, as in you could do the tanks in parallel with shuttle external tanks.
Yes.
But the SLS tank is not welded the same way. The external tanks were done horizontally, but the SLS tank is done vertically, and I could never find the reason why. And I
That was
suspect that's the reason, is the welding tool was completely scrapped.
Another big factor is the external tanks were basically, the program was managed by Lockheed Martin. Boeing builds the tanks for the SLS.
Why was that?
Different team. It's actually a different approach as well. The SLS is made out of aluminum 2219. All right, which is one type of alloy. The super lightweight tanks for the space shuttle were made out of aluminum and lithium 2195, which is 30% stronger and 5% lighter.
So, I guess a question.
And that's one of the reasons why the super lightweight tank was so light compared to the SLS core stage.
Well, didn't they?
We continued the process of using the super lightweight tank manufacturing with the 2195.
The original ET wasn't friction stir welded, though, was it?
Yes, it was.
Oh, it was.
Well, okay. The first handful of flights with shuttle, I don't believe they were. I believe the friction stir welding came in with the lightweight tank, which was, I don't know, half a dozen flights into the program, maybe. And then came for about half the program. And then the super lightweight tank was developed. And that was definitely friction stir welded as well. And that was the 2195, which created a massive improvement in weight. Now, SLS decided to go back to the 2219, and that's why they've never been able to get quite the same weight factor on SLS as we were proposing, for example, for an equivalent rocket. So if we have a look at the baseball cards, as they're called, for the various rockets at some point later, we'll supply all of those. And you take a look at what we called a stretched heavy configuration, which is the full height of the 5-segment booster version. So it's equivalent to SLS. You'll actually find that our dry mass for an SLS stage is considerably higher than the real one. We were actually estimating a lot heavier than the real one that flew.
So what was your estimate?
10 tons.
What was your estimate? The number?
I'm going to have to dig that number out again. Hang on a second.
All right. While you're doing that,
I believe you made a forum post at some point saying you were estimating 10 to 20% margins on most things. The lower end for stuff that was very familiar, so the barrel sections and
actually no, we used standard.
Stuff.
We used standard, what are called NASA GRNAs, which ground rules and assumptions. That's it. And there was a 15% growth margin in the weight of most components on the core stages, except for components that were consistent with what was already in production. We still added 15%, even though our interstage hardly changed at all, and our tank domes hardly changed at all. We still added another 15% just to cover our bases.
Well, we had the thrust structure to deal with, right?
The weights. SLS core stage came out at 275 kilos. Our exact same configuration equivalent, the Jupiter 241 stretched heavy is the one that we would call it. Our estimate was 98,052.
98.
So basically 10 tons heavier than the one that was actually built and flown. So we would have gotten that as a performance bonus. If you take that same consistent percentage and roll it back into our actual recommended vehicle, which was the shorter 4-segment sized tank, we estimated it would be 75,495 kilos. If you rolled the same percentage that's the difference between our estimate for the SLS and SLS, it would have ended up at 65,648. So that would have been another 10-ton improvement on the core stage alone. 10-ton improvement in weight is 10 tons more to low Earth orbit on the J130.
Quick question. You said that the 4-segment shorter variant, right, was 75 tons, right?
75,495.
Now, I think I remember that the shuttle external fuel tank is about, 30 tons?
Something in that range,
so
yes.
Are the 40 extra tons coming entirely from the engine section and the engines?
There were a couple of changes. The thrust structure underneath the liquid hydrogen tank, the pockets inside the liquid hydrogen tank would be milled slightly differently. There would be a wiring added to the bottom of the liquid hydrogen tank to allow the thrust structure to mount to it, to be bolted to it. Basically, it's the same type of wiring that the interstage mounts to on the top of the liquid hydrogen tank. Let me actually pull up a picture here. I've got a good picture of
but David, to your point, SDS essentially is 3 rockets flying in close formation, meaning they don't feel each other loads on each other. Whereas when you put everything in line, I mean, parallel burning structures tend to be structurally more efficient.
Yeah.
If you think about the SRBs, they're essentially holding up the oxygen tank, which is where all the weight is.
So I think
this probably weighs anything.
Yeah, this goes into an interesting discussion here. And it's one of the questions that's been asked a couple of times. It's been asked on NASA spaceflight. Woods 190 asked the question on NASA spaceflight the other day. And I said I'd bring it up in the discussion, which is would the interstage and the rest of the structure for a shuttle external tank have been good enough to fly a Jupiter 130 at least, pretty much as is, without modification. And so what was happening is we were taking the wiring that allows the interstage here to bond to the top of the tank and just replicating it down here at the bottom of the tank so that we could mount the thrust structure to it.
I've got a good image of that, Ross, if you want to see it.
And so the only real...
second.
So with that, the modifications, obviously you're going to take that truss structure off that mounts the shuttle.
Exactly. Now, you have to understand that the external tank actually is a lot stronger than it would necessarily be if it was just an axial rocket with the engines mounted directly underneath, because you have the shuttle engines offset from the center, thrusting in to the side of the vehicle. There's 1.5 million pounds of thrust coming in at an angle, which actually creates some very interesting loads at all of these connection points all through here, and also up at the front of the bipod area into the liquid oxygen tank and the interstage. So there's actually significant amount of reinforcement to distribute all of the stresses and strains through the rest of the tank. Now, we had an analysis done in 2007. It was managed by one of our contacts at Marshall, but I think the analysis was actually done at Glenn. I could be wrong. I'd have to double check that. But it came back and they basically took a shuttle external tank, ran it through their computer analysis system with the modifications to turn it into an inline structure. The one thing that wasn't included was the actual shape of the thrust structure. They came up with just basically a system for transmitting loads into the bottom of the tanks. They didn't actually have our thrust structure for that analysis, but it was the loads into the tank was what they were interested in. And it turned out that we hit a factor of safety, which is the bottom line requirement, of, I believe it was 1.46. And for human rating, it has to be a minimum of 1.4. So we were actually on the money. We could have used an external tank with hardly any modifications for a Jupiter 130.
I imagine you
And
would
the
have had
study
to...
came out. The really interesting bit is, with the smaller upper stage RL10 configuration that we had, and the fourth engine on the bottom, we actually hit a 1.39 factor of safety. So we were right on the cusp of being acceptable for a Jupiter 246, with no changes to the liquid oxygen, no changes to the liquid hydrogen tank at all. The milling profile of all of these pockets was different to distribute the stresses from the shuttle. Every pocket was different throughout this entire structure. I think these rings got to kind of some sort of uniformity, but back here, every one of these pockets was milled differently around these structures. If we did not change it at all, we met the requirement for Jupiter 130, and we were right close for Jupiter 246. Not for 241 with the J2X engine. We were a little further away for that one. But for 246, we were very close, and it would have only taken minimal changes.
Ross, quick
But that was an
question.
interesting question that was asked on NSF.
I've got
I
another
just
one.
wanted to address that and just make sure people understood. We could have basically flown with a near unmodified external tank, with the obvious exceptions of the thrust structure, and changed the dome at the top.
Ross, I've got a quick question about this for you from somebody on Twitter. He's asking, I don't know, I'm not sure what this means, but I'm sure he does, and I'm sure you do. He wants me to ask if this pulls from the NLS Cycle 0 analysis.
We've got those, yes. I actually have those. I can show some of those here. It does actually show precisely that in there. So here's the structures one, and I think it's about page 133. Let me just zoom down here a bit. Oh, this is going to take a bit. Hang on. Come on. I believe it's.
But in some ways, these are kind of hypothetical questions at this point, right?
I think so.
I'm
Yeah.
looking for
No.
option
All right.
two,
It's a bit
Ross.
further. Where is it? Hang on. Oh, here we go. Yeah, this was the drawing. This is one of the
I
pieces
remember
to
that.
take a account of. You can actually see this is the axial design load limit, and you can see the stresses inside the external tank from the side loading, because the engines are offset from the center line, and you can see the same stresses are marked in here as well, and also here at the bipod area, you have similar stresses up here on the LOX tank. Well, we remove all of those stresses by going with the engines directly underneath. It's like the old-fashioned Coke can. Back in the 80s and 90s, they used to make them out of slightly thicker material. You used to be able to stand on them when they were pressurized. But if you laid it flat on its side and tried to stand on it, it would crush immediately, because pressurized structures don't like to be crushed this way, but they can handle an enormous amount of crushing this way. And it's essentially the same story going on here. So even though we had a lot more weight on the top of the rocket, it was able to handle it because of the strengthening that it had had due to the side loads from shuttle. Now, we would have implemented a program to optimize it further, but we didn't have to do that until the Jupiter 246 was coming online a few years later. So we could have started flying the Jupiter 130s with basically hardware coming straight off the shuttle production line.
That's a key point, is that part of our overall plan was not to try to do everything at once, but make sure everything that we did was built on itself to the next stage, right? And you also have to keep in mind, there was no commercial crew cargo to space station, so we were really looking at this thing to support the International Space Station, hence the Jupiter 130 configuration.
Okay, Philip, you wanted to share something?
Oh yeah, I was just gonna show
Hopefully, I answered that question.
Yes, he
I probably
says
went into a
that's
little more detail than anybody was looking for.
he says that is exactly what he wanted to hear. So you did an excellent job with that question. He does have another question that I would like to know the answer to. Okay, well, let me find it real quick.
Philip, your artwork is stunning.
Goodness gracious, that is really good. He also asks about something, the J2XD, the G2 variant that was from DirectV 2.0. Can you guys talk about that for a little bit?
I'm actually trying to remember. The J2XD variant.
Well, Ross, this all came down to the same issue that what works, is it optimal? But if it's available, right, when you're time and budget limited, letting perfection be the enemy of good enough, so to speak. Meaning, because remember, when you're developing a lunar mission or any kind of beyond Earth mission, you've got a ton of other things to spend money on that doesn't even exist, right?
And that was the big problem that we always had with the Constellation program. The policy was great, but the execution, they couldn't afford a lander.
Correct.
And that was a 7-year development minimum, probably a 10-year development, and they weren't even putting $1 towards it.
I mean, why spend money on something that's adequate and use your dollars to something that doesn't even exist, like Orion, obviously, and the lander, right?
One of the common things that we kept saying was we're going to have a beautiful, shiny new rocket and nothing to put on top of it.
Or we're going to have a rocket with nothing to go somewhere.
Yeah,
right?
And I hate to say it, but
that's a great way to get
kind of where SLS is. It's a shiny new rocket, and we still haven't got a lander to put on top of it or anything.
Well, we got Orion.
We've got an Orion capsule.
Yeah, but that's the commercial cruise, the commercial lander side. That's part of their architecture and our structure. So that's to be expected.
Mm.
And the national launch
This
team,
was the stuff I have to say I was most proud of in the AIAA presentation, when we went into all the different types of lunar architecture that were possible. That was brilliant work. I have to say that the whole team pulled together on that.
That was a really nice presentation.
If you don't take anything else away from this conversation, look up our AIAA paper and just read through the lunar architectures section. There's a whole range of different architectures, from going straight to the surface, direct ascent type approaches, through to propellant depots in low lunar orbit or out at one of the Lagrange points, and all these different approaches to get there. And we brought together a bit of work from here and there and everywhere that was applicable to it. And oh my God, I have to say that was a beautiful piece of work that the team pulled together.
And we'll make sure to put that in the description of the video once the stream is live. So definitely, once this is over, go check out those links in the descriptions for sure.
We'll get those to you, no problem.
There's one thing I also noticed about that presentation. You guys are one of the few people I've noticed who took into account the plume of landers kicking up regolith particles, because in the airless atmosphere on the moon, they go forever, and there are very few people who take into account what direction you come in to land, where the satellites around the moon even stand when you come into land, because you essentially create a ring of debris that can go as far out as orbit. Some of it.
I mean,
it's something that needs to be taken care of.
When Starship lifted off back in April, it dug a dirty great hole in the ground.
It did, a big hole.
But it's interesting. Even if you just look at a Falcon 9 coming back and landing on the ASDS, look at the amount of dust it kicks up, and that's just a bare piece of metal.
Oh, and LZ1 and 2 as well.
Yeah. Now, those are flat concrete. Those have been cleaned off and hosed off before the thing comes into land. and they're still kicking up that much dust. Okay, what does the lunar surface kick up? And
Well,
like you say,
if you
once
wanna
a
land
particle is
next-
in motion on the lunar surface,
Mars.
it's not slowing down anytime soon.
If you want to land near your lunar base, the last thing you want to do is destroy it in the process, right? So
Right. You don't want to sandblast it, right?
Yeah. And the exhaust velocity coming out of a Raptor engine can accelerate, I don't know, a bullet-sized piece of lunar regolith rock
To bullet-sized speeds.
to well in excess of bullet speeds. I mean, I would say 3,000-4,000 miles an hour is definitely possible.
Woo!
Hey guys, there's a decent question here on YouTube about the alternatives to Altair and the vehicles themselves, but just kind of maybe to encapsulate maybe what the question's asking, like how much we didn't really consider Orion's design or Altair's design. It was only ever about the mass, right, and the volume requirements that we had to deal with.
For the most part, we did
most
come up
part.
with one concept of a Mars shield to allow the lunar lander to actually do an entry into the Martian atmosphere.
I think Ross and I actually spent a considerable amount of time looking at different concepts of the lunar lander and how we could make it safer for any structures that were on the ground.
Lewis, you covered some of this as well in your video a year ago, which I'm sure David will also link when this is done.
Yes, there
Yeah.
will be links to that.
Here,
We have another
Oh,
question.
sorry.
here we go again. So this is just to give you some ideas as to some of the things that were possible.
There we go. Yeah.
Oh, there you go. There's the Mars architecture.
AA paper, looking at just a couple of pictures of the architectures that we were looking at, and we had this surround unit that surrounded essentially a lunar lander.
Is that Orion?
Yeah, that's an Orion capsule up there.
Oh man!
So the Orion would actually go to the Martian surface.
Wow.
And the thing about this architecture, it builds on what you were saying earlier about sort of everything leading on to each other, because you don't just go straight to this. You start with something a bit like this that's
Right.
lunar, and then you do something that's a bit like that, but then it's an L2 thing, or it's a refueling depot, or it's an asteroid
Exactly, we
mission,
build it.
and then you get to something like this. So it all leads up in sequence.
Yeah.
Well, and also
Yes.
Buzz wanted me to work on what they call the Aldrin Cycler. I didn't have the time for it, but he got a great guy at MIT to do it. It's a good study. But basically, you have this vehicle that cycles periodically between Earth and Mars, and so you just catch up to it once in a while. Yeah, well, I mean we're probably getting ahead of ourselves talking about Mars, of course, but it was
Yeah.
kind of
Oh, yeah.
fun.
Yeah, but I mean, this is the end of that section. But like you say, it starts slow and builds up. But that's a section I would definitely say anybody watching this who hasn't taken a look at our AIAA paper, I'll get there in the end, from 2007. That's definitely something to go take a look at.
And
Hey,
propellant
Ross.
depots were central to it.
Yeah.
That's
So
another.
that's-
That's another fun thing to talk about. Depots.
Hey
'Cause,
David, before you do that, can I share something just real quick? I just
Oh,
want
yeah.
to get back to that. I just want to get to that last little thing on the spacecraft question.
For sure.
One of the funky things about Direct was always this fairing that kind of flared out. That was driven entirely by Altair size at the time.
Which was designed for the 10-meter
Yeah.
Oh,
CALV.
So whenever you see that weird flare on any of the Direct designs in Kerbal or whatever, it was Altair's fault.
Okay, so
Is that-
I
that
have
was
I have
the-
a fairing related question that I asked this when we were at the Kennedy Space Center, so I know the answer to it, but I want everybody else to know the answer to it. Why, with SLS, as I don't have a Block 1B with me, but I'm sure you can see, hold on, I'm sure you can see that the Orion it has the service module fairings, and then with EUS there's the payload fairing underneath it. But you guys, you put Orion's service module inside the payload fairing. Why did you do that, as opposed to just having service module fairings like SLS does?
We didn't always.
Oh.
So what was the change then? Why did you?
The
And then,
modification
hold
to
on. Can
that
I just
was-
point out that this is basically
Altair.
this is basically the EUS. That is the that's the USA. That's basically the exact same thing as the universal stage adapter that is on SLS right
Correct.
now,
Yes.
or being
Yeah.
built. Actually, they've already built one of them. It's in Huntsville, I think. So that's already.
At the red line between the bottom of the service module and where it meets the payload fairing, we had an analysis done, and because that payload fairing is not a pressurized structure, it's actually surprisingly weak compared to the pressurized structures.
Mhm.
And we were finding that that at max Q we were getting shocks off the nose of the launch escape system, shocks off the side of the Orion capsule, and then we were getting a rebound shock right in that area. And so we were actually afraid it might buckle. We could either strengthen the heck out of it and add a lot of weight, or change the design. Well, because these are basically throwaway panels on the outside of the service module anyway, let's just get rid of them in the design. And so we reprofiled the design of the boost protective cover over the Orion spacecraft so that it transitioned a very smooth curve into the structure of the payload fairing. So we had no shocks at all being formed around the payload fairing.
So then I guess another question is, if that's the case, why is NASA doing it anyways with SLS?
I have my opinion, but I think Chuck should say something if he unmutes.
Well, I really can't speak for NASA, but my opinion is that they really haven't looked at that yet. I can't say that's the actual case, but that's the feeling that I get.
So do you think there could potentially be problems on the first Block 1B flight?
Yes, I do.
No,
Oh.
they're analyzing the heck out of that, guys.
Okay, that's something interesting.
I think they've probably encountered something broadly similar, but they've just strengthened the payload fairing to do it. And this actually goes to a point in Lewis's video. Towards the end of Lewis's video, he makes a couple of points in there that we published information about the short core stage working with 5-segment boosters with an extra segment stuck on top, but still attached at the 4-segment attach points. All right. It's an interesting point that Lewis actually pulls out in the video, and it's because we never published the configuration that would ultimately become SLS, what we called the 241 stretched heavy. All right. And this all ties together here. The reason why I think NASA didn't do that design is an old reason. It's one some of our audience will cringe at, and I apologize. I didn't want to believe it at first myself until I experienced it, but it is true. NASA doesn't want to do anything that isn't invented in NASA.
Oh.
Not invented here. And so this was a clever thing that I actually think the team did at the very end, right towards 2010, right at the end of the project as it was closing down towards 2011. We withheld the Jupiter 241 configuration from all of our publicity materials, the stretched heavy. We showed the 246 and we showed the RL10 versions and all the other bits and pieces. And we showed the 4 segments core stage height with the 5-segment boosters, but we never showed the stretched because we wanted to give NASA the room to claim it.
Yeah, David, you have that. We have it was that
Yes.
diagram stayed internal.
I made some renders of that, and I put some of those renders in my recent video. But if you want to pull that up, we can talk about the stretched
Ironically,
heavy.
I'm having
Yeah,
trouble finding it right now.
Oh, really?
Yeah, we just realized if we lay claim to it, and let's be honest, by that point, by 2010, 2011, the J2X was well into development. The 5-segment boosters were well into development.
Oh, hold on, Ross.
The writing was already on the wall. That was the way NASA wanted to go.
Let me interrupt real quick. Philip, if you can't find it, I know for a fact that if you scroll through Steven's Twitter account on his pictures, there is a 246 stretched heavy somewhere in there.
I'll pull it up.
Ross, that's actually the one we showed at NASA headquarters when we had that meeting after.
Yeah, every time I need to go find the 246 stretched heavy.
Do you want the
there it
241
is.
Yeah, there
or
it
the
is.
246?
And
That's the 246. I don't know that I did a 241, did I?
I've never seen a 241. I've only seen the 246 stretched heavy.
No, this is the only
The
challenge.
241 was basically an internal document.
And what I really think is crazy is just how similar this is to the Block 1B. Like, Block 1B is literally using 4 RL10 engines, and you've got 6 right there. Like, it's...
I should point out, the reason why we've got 6 on there is so we can have 2 engine out capability.
I imagine SLS doesn't have that, does it?
All of the performance requirements, all of the performance documents that we issued assume 2 engine out. 2 engines failed to start the very first time they're needed, just runs on the other 4 for the rest of the mission.
Ooh.
All of our performance targets just actually used 4 active engines, but we had 2 spares because, let's be perfectly honest about it, in a program that costs a couple of billion, what's a couple of RL10s between friends?
Right. Just a couple RL10s. Also,
And if it gives you engine out capability, that's probably worth. I mean, the cost for those was at the time in 2009 dollars. I think it was like 10 or 12 million an engine.
Yeah, I
It
think
wasn't gonna
it's
break
up to
the bank.
I think it's up to 20 million now.
Yeah.
While we're on this picture, somebody in the comments, they didn't ask a question, but it reminded me of something I want to ask. They said, "God, I love that engine section." That's one of the things. That's one of the things I want to talk about. Is here. Let me. I can't pull that one off the stand. Let me. There we go. SLS. It has a different engine section, or a different shape of an engine section. Can you guys talk about why you chose that design of engine section as opposed to the just continuing the cylinder?
Wait a minute. We're not, this is the part where we're going to talk about the boat tail, is it?
Yes, this is the boat tail.
All right.
I know you've got a bunch of stuff you can show us, Philip.
Can you bring up the 4 engines in line, Philip?
Yeah.
Yes, let's start with that. Let's start with the inline ones, because that's the interesting. That's like the iconic direct engine section that everybody knows and loves.
There was a very specific engineering reason for that.
You guys see the boat tail there?
There it is. There's the iconic boat tail
Yes.
that everybody likes to build in KSP.
I don't know who wants to start with the reason for this. I thought the
Okay,
initial
all
reason
right.
was RS-68s, but
That's exactly right, Philip.
Yeah. That's
It
right.
was base heating. Now, if you recall, the original CALV that came out of ESAS used Space Shuttle main engines in 2004-2005 timeframe. That very quickly changed over to RS-68B engines because they were cheaper to manufacture, and for various reasons, due to efficiency, that dictated going to the larger 10-meter diameter structures, and it necessitated going to 5-segment in order to be able to get sufficient performance to get it to orbit and actually do anything. Highly inefficient. They actually ended up adding a 6th engine, which was ridiculous, quite frankly, and the arrangement they had under there was
There's just a ring
definitely a
of them.
Kerbal special.
Yes.
That's
Wasn't there
what
some
I'll call it. I
concern
can bring
with-
up a picture if you're interested later.
Ross, there's
Um,
also concern with the ablative nozzles, right?
Exactly. That was the issue that killed the RS-68 on the CALV. At the back of a rocket, for those who don't know, you get an area of negative pressure. It's regenerative gases coming off of the plume. All right, the rocket punches a dirty great hole in the atmosphere as it goes through the air. that basically creates a vacuum area around the lower part of the rocket. And that sucks up some of the exhaust gases from the engines. And it recirculates at the bottom of the rocket and just goes round and round and round, heating everything up around there. The studies came through from, I believe it was Marshall, that the RS-68B with the ablative nozzles could not survive that environment on the Ares 5. And that necessitated the entire design to go back to SSMEs, even though they were a lot more expensive and a lot harder to produce.
Quick question about
that. Was the core reason for it.
It was basically
we had tried to get around it by having this boat tail shape that allowed the airflow to come down around the side of the rocket on two sides of each engine.
Oh.
And the most dangerous part of the base heating was coming from the SRBs.
Take those hot gases away.
Hold on, Ross. Chuck, what were you saying?
The most dangerous part of the base heating was coming off of the exhaust of the SRBs. Those were the ones that were really hot.
Yes.
Yeah.
Quick question, though. A lot of people, some people know that with the Saturn V, what they did was they, on the F1.
Put that image back up again, please.
Yeah, that was useful.
Yeah.
Hello, Saturn V. On the Saturn V, a lot of models just show the actual F1 engines. But when you look at the video, during launches, the F1 engines are covered in some kind of substance.
Yeah, they had insulation around them.
It is a reflective substance to keep them safe from precisely this reason.
Was that ever considered for the RS-68?
People did look at it, but the problem is the ablative actually needs to shed heat.
Oh, so they couldn't combine. Okay, that makes sense.
Exactly, and so those two technologies don't work. So you would have had to have gone to the RS-68 Regen, which was an option. Honestly, it's quite an interesting story. I was actually called one of the guys who did the study on this base heating issue for NASA was actually on the direct team.
Oh, really?
Yeah. He called me like 10 minutes after the results of the analysis came through and were confirmed. And I called the rest of the team. Chuck and Steve and Philip and blah, 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 the other names. I won't name everybody. And I think I am 99% certain our entire team knew about that issue before somebody plucked up enough courage to walk into Griffin's office and tell him.
That's about fact.
I remember that because I started changing all my models over to SSMEs.
Exactly, yeah. And that was the dawn of Direct version 3 because of that RS-68 base heating issue. And it turns out in that picture of Apollo, if you go back to it again, if you could, sorry.
I think I closed it, Ross.
I just want to point something out with that. If we bring that up a second, look how far up the side of the first stage that heating actually goes. If you haven't got it there, I have one here.
There it is. Okay. Yeah, that goes all the way up to the liquid oxygen tank, doesn't it?
Look at that. The entire bottom half of the S1C stage is covered by flame.
That's incredible.
Recirculating gases that are percolating up the side of the rocket to the point where there's a barrier layer, essentially, and the air is splitting and taking away the gases. But they have to work their way all the way up the side of the rocket before they meet that barrier layer and are taken away.
So Ross,
every rocket experiences this, but the Saturn V is one of the only ones that was large enough to really see it. If you look at videos of an SRB separation on shuttle from the cameras on the SRBs as they're jettisoned, you can sometimes see the shuttle flying away, and on the back of the external tank, you'll see it's all scorched.
Yes, there's actually.
Ross,
I wish I could pull it up.
Issue.
But there's
every rocket suffers from
There's a really good video somewhere out there. Maybe somebody can pull it up eventually of the space shuttle during a launch, where all of a sudden the bottom of the external tank just lights on fire from all the that effect.
That's exactly what's going on. It's these recirculating gases caused by the rocket punching a hole in the air, creating a vacuum down the sides and underneath behind it. And then the gases from the exhaust, some of them just recirculating back into that vacuum spot.
Okay,
And
so
they just
Ross,
go round and round and round in a circle until they're drawn away by the outside air.
Real
Ross,
quick,
Chuck,
real quick.
Steve,
I
I
need to
have
interrupt.
to ask.
I need to interrupt for just a second. Thank you, Matthew Faustini, for joining the channel. Okay, now you can continue.
Sorry, I just have to ask the three engineers here.
Oh,
Is
yeah.
there anything distinct about the Boattail design that prevents the recirculation, or is it just getting the engines away from the SRBs as much as possible?
That's part of it, right? They're further away, plus
Yeah,
the
it was to create
airflow.
more airflow down low when the airflow was still attached to the vehicle. And then there was also another factor, which was the design of the MLP.
Oh yeah, Ross, go
We
into
had a
that.
picture earlier where we showed the arrangement of the MLP during or the way we wanted it during direct. I can actually bring up a picture.
Basically, we
here.
want-
Ross,
Maybe.
I don't want you to bury the lead here. That the story is that we got a lot of help.
Oh yeah, yeah. But what it was also we wanted to separate the shock of the SRB separation of the SRB ignition from our main engines. We thought there was going to be a horrible interaction between the two. Our study said that's a problem area, and so we redesigned a shuttle MLP so that the SRB chambers had walls on both sides. There was a completely independent chamber just for the main engines of the core with walls in between, 25-foot tall walls, the height of the MLP. And so the shock coming off of the SRB ignition should not impinge anywhere near as much on our main engines as they do on SLS. And that was a major design issue for SLS.
I've got
Yeah,
another question.
those shocks coming off the SRBs are insane on SLS. We saw it in person. It was
Yeah,
There's a video, the video of the actual launch.
of the SLS lighting up and lifting off.
You can
And
see the shockwave.
You can see them.
You can actually see the shockwave. It's incredible. Also, I've got a question. We talk a little bit tangentially about Ares 5. What did you guys think when NASA released that design for the Ares 5, where they've realized that they can't solve the heating with the RS-68s where they are, so they move them to the side of the Ares 5 and give these incredible fairings on the core stage of the Ares 5. What did you think about that?
I have a picture of it here.
You
Let me
do?
dig it
Oh,
out a
thank
second.
you. I want to show that so badly.
It's heinous.
It might
Well,
be.
There's no other word
here's
for
the thing,
it.
guys.
It might
You know,
be
when-
the worst design I think I've ever seen in a rocket.
Here's the thing, guys. You know, I've been an engineer a long time, and you start with an initial concept that's fairly straightforward. At least you think it is, and you run into problems. And if the second you hit a problem, you just say, "Oh, throw up your hands and start over again," you're not going to get anywhere, because no matter what you're doing, you're running around problems. So it's kind of an interesting balancing act between being stubborn but not being stupid, for lack of a better word. You got to be stubborn, because simply because you're a problem doesn't mean that you're just, as I said, just going to run away from it. Same time, if you have a configuration that just keeps generating problem after problem after problem after problem, sometimes you got to kind of
You're gonna be like, it's time to get rid of this thing.
time to rethink maybe the overall approach.
Ross, were you able to find that Ares 5?
Here we go.
Ah, yes, the single worst design I think I've ever seen in my life.
Look at these
Oh, yeah.
crazy fairings out here.
That's high resolution the image I have.
There.
Oh yeah, wow.
Look at this engine arrangement.
That
And
is
again,
literally
this
the
this
worst
engine
thing.
arrangement partly is to get the engines away from each other so that there's more space for the heat impingement.
You,
I don't
you
know,
know, you know
like
what
how
this
that's not going to create a
And
worse
also,
vacuum
they wanted to move
situation.
these two as far away from the SRBs to reduce the amount of shock during the ignition.
and you-
Right, but Ross, you're going to get more circulation under that. You're
Yeah.
punching a bigger
Yeah,
hole.
these fairings are just going to create a worse problem.
and
And,
I'd like
and
to.
your thrust structure from getting an engine that's thrusting in this axis into the structure here. Wait a minute, how? What? Where? When?
And keep in mind, this is all coming from the 10-meter tank, and that's completely incompatible with the existing system. And again, it just starts to derail on you. Of course, the Ares 5 had to be so powerful because the Ares 1 wasn't.
This was where the program died. This is where that program died.
That's what I would like to touch on a bit. Is like once they start making excuses like this, you know it's over. Like
Ares 1 was suffering its own series of issues as well. The vibration environment, the damping they were having to do was all cutting into the performance. It was getting worse and worse. The issue that Scott Horowitz had actually created, the black zones, the famous black zones that all of the ELV vehicles that could have lifted Orion were supposed to have, it ended up that Ares 1 started to get into them as well.
Mm.
And I mean, it just had one problem snowballing into another, as Steve says.
Well, and to that point, Ross, they kept making Orion smaller and lower weight and throwing safety systems off of it and redundancy. And like in the Augustine, report that I gave them, I showed that, getting out of Earth orbit is only danger point number 1, right? If you start underdoing the Orion capsule, you're going to create other problems when you get into space.
Right.
Yeah.
Right. So you don't want to compromise the spacecraft. And so it kept falling on top of it. So, and of course, I don't think it hurt, or I don't think it helped them that Direct was out there saying, oh, by the way, there's another way to do this.
Yeah.
Right?
Ultimately, it did help. But at the time, they were determined to stay the course and the hell with everybody else.
And, to some extent, the help we got from the people inside NASA was almost therapy for them.
Yeah.
In their day job, they're doing something that they know is probably not going to work, that they didn't want to use their skills to hopefully.
That was the frustration that was really out there. And literally Direct became a refuge for a lot of these people.
It was a mental refuge.
This was interesting. This was the Ares program top risks at the time. Look how many of these are in red.
Goodness.
If you've got 1 or 2 in the red, your program is in trouble.
That's like 6 of them.
7.
Oh, 7?
And I hate to say it, but that should have been a sign to the management that, wait a minute, let's go back and have another look. But this is 2006. This is the end of 2006. They would carry on for another, 5 years?
Well, officially, the 2010 Authorization Act came out in 2009. I think was when they
kind of forced the hand.
And Ares 1X did fly in 2009 as well.
Yeah.
Also, do you think
that bore as much resemblance to a real Ares 1?
It was an Ares
as
1
SLS does.
It was not Ares 1.
It was a model rocket. It was a 1-to-1 scale model rocket that looked like Ares 1.
Really big model rocket, yeah.
One question I have, though. Do you think that because one of the things I've noticed is that there's a pretty big trend of, stubbornness. Do you think it could have been that they were just worried that if they had to admit that this was never going to work, they wouldn't get another moon program?
I'll let you in on a secret.
That I think, Ross,
aerospace engineers have very big egos.
Oh, okay.
That was certainly the concern, and so that was our concern too. Our objective was not to, we wanted the mission. It's just that we felt what they were doing wouldn't get there. So yeah.
Hey, Steve, can you talk a little bit about how
Philip,
the invitation?
You're like completely censored. We can't see your face.
Yeah, you're blurred.
Oh, that's weird.
But before we wander too far away from Ares 5, I do have a specific question about something I heard. I think, Ross, this was something you mentioned in the Space Show interview, which was a 11-meter 7 RS-68 Ares 5 version.
An 11-meter Ares 5?
Yeah.
That I believe you refer to as the Godzilla 7. That interview is the only source of anything about that.
I've never seen a picture of it, but when the program was coming apart, they were literally scrabbling around for any solution they could come up with.
Wasn't that the
no
vehicle?
wild idea was off the table.
That was the maximum size of vehicle that they could fit in the VAB, I think.
Yeah,
Yeah,
it was as tall as possible.
Yep.
11 meters wide, 7 RS-68s.
What was
It
the?
was,
where's the-
literally designed, as I recall from what I heard, it was designed with 6 inches gap through the door of the VAB,
Goodness.
either side.
I know what rocket I'm going to render once this stream's done. That's going to be impressively bad.
I never saw a picture of it. I never saw a
Do
baseball
you
card
think
out of NASA or
Ross?
anything.
Ross,
but-
do you think it would have
but
had
yeah,
the? Do you think they
that was going around? That was going around quite a few.
Do you
of the
think
departments
the
have done.
Do you think the Godzilla rocket? Do you think it would have had the fairings on the side for the R-68s, or
I
because
hope
that would be
not.
so hilarious to put in the render?
Ross, it would go through the door sideways, right? So
And take it out,
I really
turn it,
would
put the
hope
SRBs
not.
on.
oh, that's right. Now we get the SRBs to worry about.
I think it might have been the 6-segment SRBs. I can't quite remember.
They probably just cut a hole in the bottom of the VAB to.
Man,
certainly
I wish
saw
I had
5.5
known about this.
segment, and I heard about Dix. And they were just trying to buy enough performance. It basically boiled down to when you plan out a lunar mission, you actually do it from the opposite end. You go, here's the capsule sitting in the ocean at the end of the mission. How much fuel did we use to get it through the atmosphere down to here? And how heavy were the parachutes to break it without killing anybody on board? So those are your parameters. Then it goes to how much fuel did the service module need to get you back from the moon? And that sets part of the size of the service module. How much resources did you use going down to the surface of the moon and coming back up again? And how much did the command module use while it was left in orbit? And you have to backtrack all these parameters all the way backwards through the program, all the way to liftoff. And what you find is you have to have a certain minimum amount of mass that you have to launch into low Earth orbit at the beginning of the mission. All the fuel that's going to take you there and bring you back, all the stages, all the vehicles, all the other bits and pieces, all the equipment, all the people, all the moon rocks you're going to be bringing back, etc., etc., etc. You've got to account for it all the way from the end of the mission backwards to the beginning.
See, Ross, that's where
And so there was a minimum target that Ares 1 and Ares 5 had to lift, or they couldn't accomplish a moon mission.
So here's the deal, though,
And
Ross.
that's where the problem came
Their
from.
architecture was equally a problem, right? And so by making the staging point, the Lagrange point at the moon, you can just, every day there's a daily departure. Anybody can do it. I mean, there's a lot of vehicles that can put a pretty serious amount of mass to that point anyway. And so you just stage at that point. So
And they were determined not to do that.
You don't need to have a full-on mission with one vehicle.
Yeah.
Right?
They were determined not to do that. I mean, the architecture was intended to use both LC-39 pads. 2 rockets launching 90 minutes apart. That was the original architecture. Now,
Right.
SLS is flying, but they couldn't do a 2-launch architecture today because they've given one of the pads to SpaceX. So that's out. They can't even do those missions any longer
Well, I mean, unless they use SpaceX to do the other launch,
unless they use SpaceX to do the
which is what the plan is.
We'll give them that. We give them that.
It turns out that's actually what the plan is. They're going to
Yeah.
let SpaceX do the other launch.
Which is quite amazing when you think about it. That
It
they came
is.
full circle
It is
back
just
to using a different vehicle
yeah.
for the other half of the mission. It really
just-
is quite
it just-
astonishing that they did it.
It just happens to be a
Now,
whole lot
I think
cheaper.
I think the bifurcation in Artemis to that extent is because the shuttle systems are so well proven. So if you want to, have a successful, let's call it the first phase of this campaign, you're not going to find a more proven set of hardware than what's flying on SLS.
If
At the
only,
same
well,
time,
I-
you want a company out there that's taking serious risks but huge rewards.
I'd pick
Right.
a bone with that, Steve. Aside from the space shuttle main engines, what exactly on SLS is exactly the same as flew on shuttle?
Well, nothing's exactly the same, but it's
The SRBs are
highly
pretty similar. Also, don't
Even
forget that
the engines are different.
the
They've got new flight computers and a higher rated thrusters.
Well, they needed new flight computers because they're running out of components for the older computers.
Also,
right?
they're running
it's
out,
not
aren't they?
just from the space shuttle. SLS uses, at least for the first few missions, it uses the same upper stage as the Delta IV Heavy, just with the hydrogen tank slightly lengthened.
Yeah, and the RL-10 has been human rated.
Yes.
Hey, David, can I ask? I wanted to ask these guys a question.
Yeah, go ahead.
Can I feel like the RL10B2 that was turned into the RL10C? Did you know it actually had a negative factor of safety?
What? A negative factor
Really?
of safety?
Its factor of safety during ignition, there were 1 or 2 components on board that were actually below 1.
Really?
Oh dear.
Yeah. I was shown a document about
At
that.
least,
Thankfully,
Ross,
it didn't
at
have
least
any of those
on- Ross,
funny little letters on it.
At least
But
on paper.
I was shown a document about that, and it was something like 0.93 or something. It's like,
tells me, Ross,
how does it start?
analysis
Well,
is
it's
off.
not up to full pressure at that point.
Am I the only one
all right.
waiting to see FBI agents show up behind Ross here any second?
You'll hear a knock on your door.
Oh, all right. I've got my green card these days, but back in the early days of doing direct, I was a British citizen here on a visa.
Oh.
I had to keep my nose clean as heck.
Well, even Chris on NSF would be very, very strict about anything that looked
yeah.
ITAR at all related.
Yeah, he never allowed anything ITAR on the site, and he did exactly the right thing. I never went anywhere near an ITAR document. I wouldn't touch the stuff. I wouldn't let any of the team show me or even pass it through me to somebody else. I would put person A in contact with person B directly, and they get on with it.
Philip, did you say you had a question or something?
Yeah, I feel like having gone through this with these guys, there were some critical points along the way, versions, rebuttals, meeting with certain senators or House representative people. But I think probably one of the most critical points was being asked to be a part of the Augustine Commission. Because if we had not, we just kind of floated into oblivion perhaps. But I wanted to know from Steve and Ross and Chuck, how did that invite come about? Did you guys have to fight for that invite, or like how?
No, we were a known quantity there, and in fact, the whole commission was stood up due to this conflict, right? Due to the issues that were on the program of record at that time, the fact that there's alternates. The AAA paper I actually mailed to every single. I made 400 copies of it or something like that, and literally FedExed it to everyone in Congress and the Senate.
Did you have to be sponsored for Augustine, though? Were there any particular senators or people
Well, we were certainly on their radar, and it's kind of hard to have a discussion without, us. What are you going to talk about? So
you're talking about Shuttle C?
Well, they spent 9 days. They spent 9 days talking about a lot of stuff, Steve. There's only one day for alternate architectures. That's why.
Yeah, well, that was the key one, though, wasn't
it?
That was the important one.
And then additionally, was there any follow-up?
It was also a vehicle for NASA to kind of get themselves out of the corner they'd painted themselves into as well. So I think it was, and of course we had a political change. Mike Griffin was going to get out, and then Charlie Bolden was going to get in. So there's a lot of.
Where was Lori in that? Like, didn't Lori Garber? Where did she fit into that?
Well, she was Hillary Clinton's advisor during the campaign, and then when Obama got the nomination, she went over to his side. So she was an associate administrator, wasn't she? She was part of the transition team.
She came in after Griffin, I think.
Right. And then Charlie Bolden was...
And Scott Horowitz had retired to spend time with his family at that point.
What if
That's a whole story on its own.
What, if any, follow-up at all was there from the Augustine Commission? Because that was in...
Oh, we went... So we did the presentation, but we're, who are you guys, right? Everybody else up there, Elon Musk, the head of the ELVs, of course, NASA presented the program of record, and the Shuttle C is another alternate. So we were told to go to the Aerospace Corporation. So I went down to California, and they essentially vetted our numbers to make sure that, they weren't... Because, before that point, we had people in presentations in front of Congress saying that we were defying the laws of physics and whatever else.
Let's talk about that when we get the chance.
Okay, so you went to Aerospace
Corporation, and so we just basically, Chuck Ross and myself went down there and just presented everything we could. And frankly, we were able to get into much more technical details than you would ever want to do in a 30-minute presentation, right? The 30-minute presentation was just to kind of show the arc of the concept, not get down to the nuts and bolts. And so they basically vetted us that, no, these guys' numbers are pretty solid. So that's why we became a viable option that the Augustine Commission put in front of Congress.
Gotcha. So Aerospace reported back to the commission saying this is a legit proposal that should be considered.
Correct.
Can we talk a bit about when they were trying to say you guys were not legit proposals and that your numbers were fake? I think that is a pretty interesting topic.
Well, they actually said violate the laws of physics. But
Yes, violate the laws of physics. Why did they think your proposal violated the laws of physics? Why was
gotta
that?
remember, it's a political environment, so you're kind of you're there to put the narrative that NASA was doing, that Ares 1 and 5 were just fine. Yeah, there's learning curves and problems, but we'll get through them. So what else are you going to do? I mean, it's one of those career altering decisions if you were to suddenly tell the truth right then and there, right?
Right.
Or
And
be.
Steve made a point that I think is critical, and I learned along the way, no matter how good your numbers are, if the politics don't work,
Yes.
that's not going to get done.
I also looked at that
Yeah.
problem.
That was a hard lesson to learn, I have to say. I rejected that idea probably for the first 4 years. And it was only in the last year and a half, 2 years of the whole project that I had to just resign myself. Steve was right all along.
I look at any kind of engineering project, and by the way, this happens in private companies too. There's politics, there's budget, and then there's the physics, right? And you'd be surprised how long projects can go that aren't physically viable, meaning they are truly violating the laws of physics, so they're not going to work. As long as you got the politics and the money, they can go for a long, long time. But to be successful, ultimately, you need to have all three. You need to be hitting on all cylinders on all three, especially for government-funded projects.
Or just use private money, right?
Or just use private money, but
And have your
It's
chief
so easy
engineer
to get
and
hold
have your chief engineer be the
Richest man in the world.
the funder and the king of engineering.
well, it's not
It helps.
just that. Elon's got a great instinct. I'm sure he's made mistakes, and he admitted as much, but they learn from him quickly, right? So he doesn't attach his ego to what he thinks is the correct solution at that time, realizing that if you're doing something new, you're going to make mistakes. And you can tell if the organization is really pushing the envelope if they are making mistakes. If you're not making mistakes, then clearly you're not pushing it. So it's kind of a
That's
different
allowed him to
organizational.
just take such a
Whereas
massive
NASA,
lead.
So
of course, when NASA makes a mistake, right, it gets broadcast everywhere, and so they're naturally kind of shy taking big risks. So that's why when I look at the Artemis program, I really see a good balance between that kind of this is definitely going to work approach, but maybe it's more expensive, versus the let's do some crazy things like make a reusable heavy lift launch system that and propellant depots and other things that we've never done before. Right. So it's a really, I can't say enough about NASA, how I think they've really struck a great balance on Artemis.
So Steve, bringing it back to direct for a little bit, is it unfair or is it safe to say that one of the biggest bulwarks against the whole process was ATK? Like
ATK was definitely the least Boy Scouty of all the lobbyists that we dealt with. No question about it. They would throw money around that town like you wouldn't believe.
And that's because they wanted the 5-segment boosters and the 4 segs were a non-starter.
And I think that's part of the reason why there is 5 segments on SLS, because they said we weren't going to develop the motors for your shuttle drive or any other vehicle if it wasn't a 5
additionally,
It was actually even bigger than that. Dan Murphy, who was running ATK at the time, is on record as having said, we don't care about building another shuttle SRB at all. We'd rather get out of the business unless you give us a whacking great development contract.
So
they were basically going to walk away.
Well, look at it from their perspective, right? The kind of launch
I think
rate,
it was a hollow threat, but
no, I get it. But look from their perspective, given the launch rate we're talking about, even now, you really can't base a production line on just SRB segments, right? So, And you know, an interesting other aspect of that, the Department of Defense kind of weighed in that, well, we want those guys on board because they're a major supplier for solid rocket motors for a lot of other things that are national security critical. Right.
Yeah. Circling back a little bit to something Lewis mentioned about changing.
Philip, hold on one second. Can you hold on to that thought? Because I have something that was related to that I wanted to ask.
Mm-hmm.
Okay, so ATK, they were saying 5 segments or no segments, right? If they had been more agreeable to a 4-segment design, do you think that the ESAS could have recommended Jupiter or the LV-24 all those years ago?
Again, David, it's one of those other things when you're dealing with kind of a chaotic environment like that. Once you start spending money down certain pathways, it's usually just more cost effective to complete them versus reversing. So there's the politics, but there's also, they had been developing 5 segments, just like they had been developing Orion to a certain capability. So there comes a point where you spent so much money going down a particular path. Now, you know, the option of doing a simpler shoulder-ride vehicle is gone. Right?
All right, that makes sense. All right, sorry for interrupting, Philip. I just wanted to know that. You can go ahead now.
No, that's right. So we could have done something like this instead.
Oh, Ajax! Listen, yeah, that's a great segue.
Yeah.
So what was this? What was this very curved rocket?
This was the Ajax concept with using Atlas as 2 Atlases on either side as the boosters. It wasn't. I don't think this was our concept. Wasn't this? This has been around for a while, right?
Yeah, there's a lot of. In fact, I'd love to see some Falcon 9s on either side.
You know what's funny? There was a video where someone in Kerbal, of course, because where else would you do it? But they stuck 4 Falcon 9s on an SLS, and it's a pretty popular video. It's got like 27 million views, or something, 2.7 or something. It's crazy. But
I mean, there's tons of options you can do, but it's a matter of time and money, and you know, like for example, I always use the Grand Canyon analogy, right? At one point, the Grand Canyon was just a little stream, right, and it cut its path. Now, to try to move it over a foot would be, you know, impossible, right?
Right, exactly.
There's been so much effort and so much infrastructure and so much money spent down a particular pathway. It becomes next to impossible. In fact, it's not economic anymore to go to something maybe slightly better.
Yeah. So, Steve, back to what I was going to say about what Lewis mentioned. Since we were talking about ATK and the 5 segments, kind of like what Lewis mentioned, when you change the core diameter, it has massive effects on infrastructure, stage 0, and all that stuff. Isn't it also safe to say that when the 5 segments were a requirement, that also changed a bunch of stuff as far as this tanking size, when staging would happen, how many engines, you had to bleed all that new liquid out? I mean, there is some...
SLS is essentially putting that heavy tank almost in orbit.
Yeah.
Right now. And I've often, you know, if you compare the payload capacity of the old shuttle system, right, 3 engines, 4-segment SRBs, and add the shuttle as part of the payload, right? So add the shuttle weight plus the payload of the shuttle, right? How much mass in low Earth orbit that is versus what SLS is doing.
So in some regards, going to 5 segments, although the naive notion would be more power, more better, actually introduced more issues.
It's really, you have to look at the net thrust, right? So you can thrust numbers all day long, but if that thrust is being basically destroyed by the weight of the SRB itself, right?
Yeah.
Then you're not getting any kind of net impulse addition. I think, Ross, there is a slight net impulse addition, but it's not nearly... Yeah. It's really not 20% more.
There's also a keying between the size of the core stage and boosters versus the size of the EDS.
Right.
And for a lunar mission, you want to minimize the dry mass of the EDS as much as you can.
Right.
So you want the core stage to do the majority of the work.
Right. So yeah, there's that balance.
The 5-segment stretched with 5 SSMEs doesn't hit quite the same sweet spot that the 4-engine, 4-segment, shorter configuration actually hits a better sweet spot.
Yes.
And so that's why when we went with the smaller EDS with the RL10s on it, even with 2 spares, all right, we were actually producing greater performance for the total mission.
Right. It depends. Trying to maximize payload to orbit, Earth orbit, or you're trying to maximize payload to translunar injection. Right.
Yeah.
So that's
because these were designed to be two launch lunar missions,
right.
When we realized that the keying was so critical,
yep,
it was clear to us that was the way to go. But like I say, by 2010, 2011, J2X was so far into its development, 5 Sigma was so far into development, the writing was on the wall.
Plus the politics of it all. Right.
Yeah. Yeah. And the politics is a massive part of it.
Well, again, Artemis,
90% of it was
still a
politics
great program.
in the end.
I mean, what we've been talking about is kind of the sausage factory that occurs. You know, so it's not all about just the technical details, right? There's a lot more moving pieces in the sausage factory. But I think what came out of the sausage factory, all things considered, is a great program.
Yeah. Yeah.
We have a question from the chat. I'm gonna read it as is. It says, "Hi guys, the Augustine Commission had a company analyze the direct proposal, and they gave you raves. That report, will that report ever be released to the public, us engineering geeks?"
Well, I've never seen it, so
That's the aerospace. That would be the aerospace report, right?
That was airspace. Yeah. I don't remember actually seeing it. I'm sure you can FOIA it if you wanted to. But I don't know what. I'm not even sure what form it took.
Yeah. The upshot, though, is we were technically viable, so that's all the Augustine Commission was looking for.
Mm.
I mean, they didn't want to have an option that Congress to select from that wouldn't work.
Right.
Let's put it that way.
Well,
or had serious problems.
It would be interesting to ask them, actually, would they release it at this point? Just as a matter of historical record.
Another question, more on the Augustine Commission. Was the Augustine Commission, there was the EELVs, there was the Shuttle C, there was your proposal. Was it still considering the Ares proposal, or was that pretty much a done deal?
That was program of record, and it's that wonderful scene that Lewis has in his video of Jeff Greason looking at the cost budget there and basically saying we need another $6 billion if we were delivered the thing tomorrow, working, fully developed. The first thing we'd have to do is shut it down because we can't afford it.
The Santa Claus quote.
I think the Santa Claus quote. He actually said Santa Claus brought it to us.
If Santa had brought this system to us today, fully developed, the next order of business would be to cancel it.
Yeah, it was $6 billion short. That was the program of record, and that's what they spent the bulk of the time of the Augustine Commission talking about publicly, because they had to make it clear there's a problem here, guys. And I hate to say it, but this is the problem we spotted in, what was it, early 2006?
Yeah.
And it's the reason why Chuck contacted me and Steve contacted me and everything else happened, because we spotted it in 2006, but NASA management just, I hate to say it, they had their head in the sand for some reason.
They
were determined to do what they were going to do, and
you know, it's really easy to Monday night quarterback people, anyway, look back and see the stuff. But the point is that when you're doing something difficult like this, it's always easy to point out the problems after they show up, right? Right. And then it's also easy to say, well, why didn't you change? You have to have a certain amount of stubbornness to get through this stuff. It's not easy. It's not easy. And if you think for some reason the development effort's not going to have serious problems along the way, you haven't been in a development program before.
I'll tell you one thing to keep in mind.
There's a fine line between stubbornness and stupidity, right? Right. So it's hard to balance that many times.
One thing to keep in mind: SLS is a huge program. Orion's a pretty big program as well.
Yep.
It's nothing compared to the development of the shuttle in the first place. The shuttle is 10 times harder than SLS. And it still blows my mind that the only launch vehicle in history, near enough, that flew on time the very first time it was supposed to fly, flew with people on it.
Goodness gracious, yeah.
That just staggers me to this day. Bob Crippen and
John Young.
John Young.
Moon guy.
Wow.
And it's so crazy because John Young was on the moon when he got the news that they had selected the shuttle, right? He was walking on the moon when they selected it.
And then 9 years later, he flies the shuttle.
and it's never flown before.
Right.
That's the thing that blows my mind entirely. And it went off exactly on time. Elon.
Well, I think there were delays to the shuttle though, because it was supposed to boost Skylab, and it had tile issues that delayed it, didn't it?
I don't think it actually had I don't think it actually had a T0 time.
You don't think it did?
I don't believe so. I think they had a target. Yeah, we'd like to launch it around then, but they weren't in the countdown.
Gotcha.
So, Dave, we're coming up on 2 hours here with the. Not that I couldn't. I'm sure we could talk for another 10 hours, but
if we,
as I told Ross, if we were actually do justice, we'd have to have a whole conference on this, multiple presentations.
If there are time constraints that some of you are experiencing, we can definitely go ahead and try wrapping this up, or we could continue going. It's whatever you guys want to do.
I'm good.
I'm good. Were there any of those other questions though that David that you wanted to hit?
There is a question that I want to hit, but I want to make sure everybody's what everybody's status is on the stream. Are we good to continue, or do we want to? I'm seeing thumbs up. Steven, how about you? Okay, so we can continue. Okay, so here's a good question. Is there a story that you can share about how bad the tension between the Obama administration was versus Congress, Nelson / Hutchinson, in that 2008 to 2010 period?
They weren't very excited about the overall program itself. Fortunately, though, we got 4/5 of Congress, both the Senate and the House, to vote for the 2010 Authorization Act, and it was a single line item vote. You know how they typically package things together? This was a single package. And so at that point, they knew they couldn't veto it, so it went through.
All right.
I didn't think there was all that much tension in practice on this issue. I mean, I'm sure there were other tensions out there, but when it comes to NASA, there certainly at that period of time, there was a very strong political cadre that was supporting NASA in one fashion or another.
Sure.
They mandated a lot of decisions for NASA, which didn't help, sorry to say. Non-engineers making engineering decisions never works very well. And so the program had problems as a result of some of those mandates, and they could have been handled better. That was one of the things I wish we'd gotten a better handle on earlier. We could have met everybody's requirements, whether it was Shelby or Hutchinson or Nelson or whoever it was in Congress at the time. Every single person had their own requirement. I want to create more jobs. I want more money into my district, etc., etc. That's just the way Congress works. And the NASA cadre had support from outside in the usual you scratch my back, I scratch yours fashion. And so it all boiled down to them at the end of the day. I wish we had made a better argument to people like Shelby that, yes, one gigantic, uncancelable project, a rocket, doesn't have to be the be-all and end-all of the spending in your district. If we make that rocket smaller, but we add the lander, the lunar HAB modules, a rover, the scientific experiments, and we all do that in your district, it'll still be the same amount of money and the same number of jobs you're creating, and that pluses up your re-election opportunities, which is what it ultimately boils down to. That's the big ticket in every
at the end of the day, he's still one vote, right? So yeah. I heard this thing. The perfect weapon system, the perfect weapon system is built in every state, right? So, you know, and I would just want to add one thing. The 2010 Act, I think, what they also did is they did kind of move closer to kind of Lord Garver approach to have more commercial aspects. So that's where you kind of get that bifurcation between how the crew gets to the lunar vicinity versus how we get them down and get them, you know, in the lunar base and all that stuff. So as I said, it's a part of the sausage factory, right?
Yeah.
As Ross says, you got to get the political support, which many times just comes down to jobs. But at the same time, you only have so much money to spread around to begin with, and then there's the technical aspect when you actually do it. So I just say, I'm sorry, I've said it enough times. I think Artemis is a great program. I think they've really hit a good balance.
I
We
think
we got that in place by the end, when, like, the 2010 kind of period. We knew what we were doing on that front by that point. But if we'd understood that in 2006, 2007, I think we could have actually changed the whole direction of the program more effectively.
I don't know, with Mike Griffin there is Ares 1, Ares 5 or the highway. So.
Don't forget though, at the ISDC here in Orlando, we met
right.
that chap who worked in Mike Griffin's office. I forget his name. I've got a card somewhere around here.
No, we met him in person. I don't remember.
Yeah, we met.
Probably one of the names you got rid of, right?
Yeah, one of the guys actually worked in his office, and we got a chance to have just a quick conversation with him. And I wish I'd actually sat down with him for a couple of hours and gone over it all. But he revealed to us Mike Griffin hated the stick.
Then why did he recommend it?
What? No, wait. The astronaut corps was coming through that, because remember that came out of Columbia, right?
Yeah,
they're losing their friends. That these people live next to each other. They know their kids, their wives, you name it. I don't think people really have a sense of how tight that community is.
that was the whole separate crew and cargo.
And these
I
are all
think a lot of it
A-type
came down to-
personalities.
I think a lot of it was Scott Horowitz had pushed for it. And once he left, Mike Griffin was able to express himself a little bit more on that score.
And he was really, again, after the largest rocket system ever invented by man kind of shtick, right?
It's funny
The
because
next Werner von Braun. In fact, I'll tell you one more funny story. I learned how to design rockets and trajectories based on a book him and Jim French wrote. So I learned everything I know about rockets from Mike Griffin and James French.
His lectures are brilliant. I have to say, his lecture series is brilliant. All the papers he writes are very clever. Yep. He says exactly the right thing every time he opens his mouth in public. But then what he actually did with the program, I don't get it. To this day, I still don't get it. I have a feeling if I ever stepped into the same room as him, I'd probably get a black eye. But I would love to sit down with him for an hour over a coffee and just say, what was going on?
With who is that, Mike?
Mike Griffin. I would love to hear that conversation. David, go get Mike Griffin on an interview and see if you can figure that one out, because Ross, to this day I still want to figure that one out. Ross, I don't get it.
If I manage to get Mike Griffin on an interview, I can promise you'll be the first person to know about it, and you will be invited.
I'm not dialing into that one. I'll watch that one on record. On repeat.
All right.
Yeah. Elon has some things to say about Mike in his biography that Walter did.
Oh, really? Yeah. What did Elon? That's interesting.
I'm not going to ruin it. Go read it.
What? I don't want to pay money for something. Come on.
I'm not going to be known.
Which biography is that? The biography by Laurie?
By Walter Isaacson. Because Mike, the timing probably lines up here. Mike was on the airplane with Elon when he went over to Russia to get the ICBMs.
Was he really?
Yeah. Really?
Yeah. And it's a story that he tells his story to Walter about on their trip back. What Mike was up to on the plane, and
was he designing Ares 5?
No, I mean I'll give you the short version, but essentially Elon was running through PowerPoints like Stephen Ross and Chuck used to do on the flight back, and Mike Griffin and I can't remember who else it was that was with them, another space name, were just enjoying themselves with cocktails, and Elon has a very distinct memory of thinking, I don't know, this guy's actually that serious.
Yeah. It's funny, though, how incredibly delayed the entire going back to the moon effort was by Constellation, the Constellation program, especially once you realize like what this kind of stuff was actually going on.
What do you think the overall delay was from the? If they'd gone to direct right away?
Yeah, that's a good question: how soon could we have gotten it if they had just done direct initially?
Okay, hang on.
Because remember, they had the vision for space exploration, so there was a delay there, right? Because there's a whole year that we burned fighting over ELVs, brand new rockets, shuttle derived, whatever else. And then when Mike showed up, he said it's going to be shuttle derived, and he had the politics behind him, right? And he had the astronaut corps behind him with the Ares 1. So I think that was kind of as I said, it's politics, money, and physics. You got to hit on all three to make it work. And I think he had a good combination there. But my frustration was that the Ares 1 kind of upset the apple cart to go down to the two more closely derived shuttle vehicle approach. Because as soon as you buy into a two-launch architecture, you might as well just launch two of the same thing, right? It just makes too much sense.
Did you guys ever hear from the astronaut office on what a Jupiter 120, how they would have felt about getting on that thing?
They like the fact that Orion fashion. They like the fact that Orion wasn't being thrown into the parking lot on a regular basis and safety systems stripped from it to keep the weight down. As soon as we started talking about stuff like that, the Ares 1 didn't sound so safe anymore.
Well, because even Jupiter 130 co-manifested payload with Orion, right?
Correct, because we were supposed to support the space station. There was no commercial crew, right?
And there was lift capability on top of whatever Orion already grew to, right?
Correct, right. And it was going to be basically the tug. It'd be a stripped down Orion, right? Because it just has to go to Earth orbit. But that's where the commercial crew came in. So I think, and that also freed that requirement. Remember, the Ares 1 was also supposed to be that vehicle. It was supposed to support the space station while they were building Ares 5. So they had a similar kind of philosophy going on there.
Yeah, except I noticed in one of those timelines I did, maybe Ross will show it here, is even in the Augustine Commission, I think Jeff Greason mentions that splash of ISS would be 1 year after Ares 1 was ready.
Yeah.
It was going to come down in 2014 by Augustine time, and then it's been extended
to the
2030s.
So my prediction on that is they'll splash it once the lunar base is up. Just a little prediction, unless there's some hardware.
I think there will
be won't allow it.
I think there will be a slight overlap between Gateway and ISS, just so that we can say we still have a space station. You know?
Yes, I could see that.
Also,
answering your question, this is from 2006. This was based on the timeline that Constellation were talking about in 2006. So this is right at the beginning of the whole process with Direct.
Yep.
This is the what if they had changed immediately. So this was, they were trying to get an Ares 1 crew rotation in 2015. I believe that when I saw it. This would have still been, I think, the 4 segment and the SSME, which proved to be impossible.
Right.
All right. And then Ares 5 was out here in 2018.
2018 for Ares 5?
In about 19.
This schedule came out when, Ross? 2000?
This was 2006. This is what Constellation was telling everybody in 2006.
And so, David, when did Ares 1X actually go for its
2009.
test?
It went while the shuttle was still flying, which was pretty wild.
Oh, that's right. Yeah.
It wasn't even
in the sky.
I think it was the last thing to fly from 39B until SLS, but it was not the last shuttle. It was not the last one to launch from 39.
And here you go. This is the one you want to look at.
This was our schedule at the same time.
There's a lot of filler in it.
The difference being, because we didn't spend all that money on the rocket, we could pay for the lunar lander and the ATVs and all the other bits and pieces.
And the EDS.
And an EDS, let's not forget that.
So if Ares 5 had not been selected, if the Constellation program had been not what it was, we could have been doing Jupiter way sooner. And we could, the first flight you're saying right there of a vehicle, like what would be, well, obviously not SLS, but the first flight of an inline shuttle-derived vehicle could have been in 2015 as opposed to 2022. So that's
actually, this is with the EDS.
That's
this
with the
EDS.
EDS.
Would have been with a set of RL-10B2s.
Goodness. And so
not man-rated. We didn't have to use man-rated for this flight.
Was that to be the first one, even though it has an EDS?
I believe so, because the EDS would have been ready. The EDS could have been produced on the same tanking hardware as the external tanks.
Hmm. That's what they're doing.
'Cause
With
that was the thing, is you could make the Jupiter core in the same line as so as in with the thumbnail of the stream. Is where that
Precisely.
image comes
Precisely.
from.
We could have a Jupiter core going and an external tank for a shuttle either side of it.
and
And
that's
then in
one
the
of the
process,
things that,
you could
that's
throw
one of the
one up
things I think
as a
SLS
test
is doing, is they're building the EUS alongside the core stages using the same diameter tooling to build it. And I think this might be wrong, but I think that the liquid oxygen tank is based on the same tooling that was their tooling for Ares 1 second stage, because I think I heard somewhere that the LOX tank for the EUS is the same diameter and uses similar tooling for that.
Wouldn't surprise me.
Here,
They were well into building the prototypes for Ares 1's upper stage. They'd done things like the spin forming of the domes, and they'd already got some ortho grid panels built and what have you. I don't think they had a full tank assembled.
I've never seen one.
this
But it wouldn't
image
surprise
was
me if they weren't using the same equipment. Wouldn't surprise me.
this image was actually done when we knew what the ET count was. We knew what was in,
Yeah.
and so this was an image just showing that 137, 138 was a spare, and then Jupiter core was right after that.
And if the Jupiter core had been in process, we were strongly recommending add another couple of shuttle flights just to close the gap even further.
Yep.
Yeah, the Augustine Commission called it closing the gap from below.
Fly the power station up to the International Space Station, which never flew in the end, which would have provided a lot more power to the station.
Also,
Fly that on it and go and do a Hubble servicing mission was what we suggested.
There's a in your simpler, safer, sooner than Ares PDF. There is a very interesting looking Jupiter with an ICPS that looks basically like a very like a short version of this guy. And it said it could have done it. It could have put humans around the moon, like an Artemis 2 mission, in 2014. Is that good?
Sorry, Ross, you want to pull that diagram back up? Sorry, I took over.
Sure.
And my guess, that would have been a free return type trajectory, meaning you just there and back.
Right. It did look like the
no orbital insertion.
Also, thank you, Matthew Faustini, for the 5 memberships. Appreciate it.
So this was just an EDS for a lunar mission. This was an Orion for a lunar flyby.
Right.
Yeah, there it is.
And this is still when we were calling it Ares 2. This is before it became a Jupiter. This is before Steve really came on board. I think this was about the time you and I were starting to really talk.
Yeah, 2006. Yeah.
Yeah.
Not to roll this back to ATK, Steve, but there's an awful lot of SRBs in this image.
Exactly. That's one of the frustrating. That's one of the frustrating things I had with them. It's like you want to sell SRBs. I've got a plan for you.
Was it ever considered to do it? Was it ever considered to do
dispose? To do it, we'll give it to someone else. I'm sure Boeing would take over the operation.
There was actually an effort stood up potentially to do that, to basically cut them out of the equation and say, well, if you don't make them, someone will. So they are still industry leaders in that area. I know they've been bought by Northrop, but that doesn't matter.
Is there anything to be gained by a disposable solid in the 4-segment range? I mean, could that have been part of, like, here, guys, build as many of these things as you want?
Well, they are disposable now.
They are disposable now, yeah. I mean, but I don't ever remember us considering them being disposable at any point.
I'm pretty sure they was just to continue using them as reusable as they were. I'm fairly certain that was on
round ones that that Discovery was going to use out of Vandenberg before the Challenger accident. And those were totally disposable.
Philip,
speaking of costs, Ross, didn't we do an analysis to see if we could get rid of the thrust vector control on the SRBs because it was inline now?
Yeah, we did look at it. I think we still needed the TVC in the end.
Okay.
We did. We had a fair amount of control authority, but those SRBs are so powerful.
Yeah.
I think we just never went there in the end.
Because that would have been a significant savings for them because of all the, the parachutes, all that kind of stuff. we could save a little bit of money on it.
Philip, real quick, I just sent you a picture. E Street Rockets is asking, what was going on with those LRBs in that picture? Is that just Ajax? It's on Discord.
Oh no, actually, yeah, no. I was actually gonna mention that there is an image somewhere. I didn't do it of the LRBs, and they're like black.
Can you post this picture up on screen so we can see what you're talking about? The one I sent you in Discord. There we go. He says he got it from an old NSF forum.
Oh, crumbs. I remember that.
Those aren't Atlases, are they? Are they LRBs?
He says it's Direct V 2.0 Thread 2. You guys probably know what that is. I don't.
Oh, now I'm dredging my memory. I think those were Atlases.
Yeah, well, the engine configuration at the bottom looks like they're SSMEs, though, the size.
And they do look a little bit wider, don't they, than the... maybe that's just my eyes, but I think they look a little bit wider than the SRBs.
Yeah.
I don't know. It's a bit low quality. It's hard to tell.
Yeah, hold on. I mean, I don't know if I know I showed these earlier, but I don't know if he...
I found the image here. It was part of our growth options study at the time. We were looking at the option of going with a liquid booster, but for the life of me, I don't remember which one.
What would have been... if you had the choice, you can pick whichever one you want, and there's no consequences. It'll happen. Which do you prefer, SRBs or LRBs?
LRBs, no question.
LRBs?
If it were outside of the restrictions that Congress had implied, shuttle derived, blah blah blah, and if we didn't have the stipulation of trying to save the jobs and all the other stuff, LRBs every time.
Every time,
you know, but
totally.
So you guys, it does bring up though something that the pad infrastructure would have to significantly change, right? Yes, SRBs are kind of on their own. They don't really need a lot of support from the pad.
But cost and everything else aside, LRBs are definitely the way to go. I mean, if you were starting with a clean sheet design, you'd go LRB.
Right. So
the benefits to the program of LRBs would eventually override any cost of changing the pad.
Okay.
Because I've done some digging on the shuttle development as to how we ended up with the shuttle in its form, and essentially the reason we got SRBs from the shuttle is because the shuttle had a hard cap of 2 billion peak funding, I think, and essentially anything that wasn't an SRB pushed over that. I think the closest we got to an LRB was a great big ugly pressure fed Keralox thing, described as an ugly duckling in, I think it was the place I was reading it. So it's one of those trade-offs where you're trying to reduce peak funding, but that increases your area under the funding over time, which is how we end up with.
There's a high quality. SLVs. Yeah, those look like Atlases. They definitely look a lot like
those
Atlases.
Are definitely Atlases. Yeah, you can see the twin engines. Those are RD-180s. Yeah.
So this was like Ajax before Ajax, right? Or maybe this was where it came from.
Well, how are two Atlases strong enough to replace that?
It looks like it could be just we're viewing it from a side profile, so we don't see that there's two there in like an Energia configuration.
That document is dated the 22nd of June 2007.
No, it is two. It is just two. Okay,
yeah,
that doesn't make sense.
Yeah.
Additionally, if we're gonna use, I was talking about Energia a couple seconds ago. That uses it's the RD-170 is on Energia's boosters, and they had 4 of those. RS-20 Atlas is just using the RD-180, and they're
didn't look like a particularly successful option. I don't know if these were. I don't think these are Atlas 5s as they are. I think these were Atlas 5s reconfigured to fit a 4-segment core stage and a 5-segment core stage.
Yeah. Well, as you pointed out in a conversation we had before, Ross, it's a good thing that no one did go this direction. We're kind of out of RD-170s or 180s right now.
Although by this point we could have switched over to something else.
Yeah.
Well, is there another Keralox engine out there that could replace an RD-180?
Honestly, at this point, you'd go Methalox.
Right. The reason
From
I
about
ask
2010 onwards, you'd go Methalox.
Well,
and if you're not going
right.
Methalox, why aren't you going Methalox?
Well, the reason I ask is because if you start out with the Atlases, and then you're flying the Atlases, and then Russia invades Ukraine, now you're using Russian engines and you don't have a rocket.
Yeah.
So,
I never thought that was a particularly good idea for any of the programs. I'm genuinely shocked that Lockheed went down that path with the Atlas program.
I mean, they are good engines. They are really good engines.
They are,
It's just
but it's a foreign asset
and they don't come from
or a
great place.
national security
Yes.
program.
Yes, exactly.
Oh,
That doesn't sound like a good plan.
Yes, especially
how
when
how about a pair of Vulcans then?
Vulcan's a pretty thick
But in
rocket.
this day and age, I'd love to see something like that with a Raptor under it.
Oh,
How many Raptor engines do you think you'd need to replace an SRB?
I don't know, 3 or something.
Just 3?
What's the thrust of a Raptor 2 these days?
I thought last I heard it was, I'm not a SpaceX guy, so I have absolutely no clue. I'm going to stop talking now.
I think it's SSNE class. It's like 500 and something thousand pounds of thrust.
well, it's 18 million divided by 33.
Yeah. So probably 3 would get you in the ballpark. And they're a lot more efficient.
Right.
So you've got a much higher ISP. So you actually don't, you can trade thrust and ISP to a certain degree.
And the LRB would weigh a lot less.
Yeah.
That's true. That is, yes.
Yeah.
Google says
I would say
Raptor is
I would say a
225
Methalox
tons.
booster with an appropriate number of Raptors under it, the size of a 4-segment SRB, would be a very interesting rocket.
I think it would be. I think you're right.
I think one of the other bonuses of LRBs over SRBs is the throttle bucket. So obviously, when the shuttle goes through max Q, it ramps the engines down and back up, and that causes a whole bunch of strain. And in most of I think all of the LRB studies I've read, they put the throttle bucket on the boosters instead, rather than the SSMEs.
And let's not forget the harmonics as well from the SRBs. I mean, there were some really interesting things done after Columbia was lost. They did a lot more studies into the chugging and chuffing of the SRBs. And what they found is that beam through the interstage of the tank actually allows the two boosters to couple with their harmonics.
Yeah.
That's right.
I mean,
And
And they never thought that would happen.
That's
But the
interesting you
harmonics
mention
from
that,
one
Ross.
syncs up with the other one, and you get this horrific pogo through the whole system.
That's interesting you mention that because that was one of the issues with the Ares 1, right?
Yeah, the Ares 1 didn't have that beam.
Right.
there.
So basically, they're sitting on top of an organ pipe, for lack of a better
Yeah.
word.
I think you said it was in one of your interviews, Ross. I think you said it was 10 Gs at 14 hertz or something,
Yeah.
and the
it was-
closest
it was
equivalent is like a
frightening
jackhammer.
numbers. Yeah. And the damping system that they had was starting to weigh tons.
I know. So those tons were coming out of the Orion spacecraft.
All right, let's we are actually going very long. We're at 2.5 hours. So what I want to do now is move on
I
to
told you we could do all a
We're
conference.
only about a quarter of the way through. It's fine. No.
but what I also want to do is talk a little bit about what Direct turned into. This guy right here. So what was the reaction like when you actually got the news that you guys were selected? How did that go?
It was telegraphed to us. We were invited to go up to DC and talk to them. And Gerst was in the room, and Doug Cook was there, and a bunch of people were on the other end of the line. And I think Michael Griffin was probably listening in, or whoever. I don't know.
I
But
think
it
Mike was
was
long gone by
basically
then. But who knows?
what they wanted to know from us was what do you plan to do next? They were frightened. I think they were a little bit frightened. What are we going to do? Were we going to keep holding their feet to the fire, or what was going to happen? And we basically said, look, we want the program to succeed. We're stepping back.
Right.
All right, we're going to try and get out of your way. And that's where we explained to them that we'd left the Jupiter 241 stretched heavy configuration. We'd laid it out on the table, literally put the pieces of paper on the table with the baseball cards and all the other stuff, with all the configurations for that configuration, which we knew they were leaning towards. We'd heard that from our team members. And we just said, look, we know this is the direction you want to go. We've deliberately stayed out of that space, so you can claim it for your own.
You know, Ross, there. So we talked about politics, money, physics, but there's also an emotional component to this. And I think we felt at that time, obviously we put our blood, sweat, and tears in this thing, and we'd lost a few, people lost their jobs along the way. And, I had gone through stuff too. My company, it's not easy to be a NASA contractor. When you're doing this
with
kind
a
of stuff.
tongue on your back, yeah.
Right. So, but this country's ability, or frankly, I think space is of international importance to take everybody's focus off of fighting wars and all this kind of stuff, and refocus it towards doing great things. Right. So, at that point, the best image I have is that you're trying to get parents to adopt a child, right? You have to walk away and let them become the parents of it. And as I said,
think about the environment at the time. Think about the political environment and everything else. We'd had the crash of 2008, and there were lots of people out of work and everything else. Yeah. And the program had just bad news after bad news after bad news after bad news, and nobody on our team wanted that.
No.
We were hurting from that.
Right. So
and it was just it's time. We need some good news, guys.
And since that point in time, I think NASA has actually massively improved the program. So in ways that, only they could.
Yeah, they certainly grabbed the ball and ran with it.
Yep.
I still have issues with the political side of the process.
Yeah, that's what's going to happen when we get political money. It's never going
to
be any other way.
I think political fingers were put too heavily on various scales here and there, and the program has hurt from that.
Mm-hmm.
I really hope that Congress and NASA learns valuable lessons for how to play those games in the future. That would be a very important takeaway for the future.
I'm glad someone put that up.
2009.
Oh, yes, the Rebel Rocketeers. I remember that.
I was wondering if somebody was going to bring that up.
I
also noticed there's no...
I still have a copy of that of it.
We still have like 20 copies of this magazine. My wife went out and bought a ton of them. So,
have you ever seen that, Lewis?
I've seen the cover, because I noticed there's no boat tail on this one.
Yeah, they drew their own. Each of the magazines drew their own.
I went back and forth with the art director on this one, and I was just happy that they wanted it to be on the cover, so I gave them all my stuff, and then this was the interpretation they did.
Yeah.
Oh, so Phil, did you know who's on the board of directors of this magazine at that time?
Who was?
Buzz Aldrin.
Oh wow!
Oh,
this wasn't by accident.
So it seems to me like Buzz Aldrin's kind of been helping this Jupiter program out in the background a little bit.
Once you know Buzz, you know everybody. You know the Kevin Bacon. He's got nothing on Buzz Aldrin.
The funny thing about this kind of stuff is whenever you give people your artwork, they'll put in errors that you didn't mean in the first place. And that's how you can tell that quote unquote ripped it off, is that it has all the errors of design that you wanted to take care of but never got around to.
Another question I just noticed in the thing, I saw the words Jupiter Direct, and then I want to ask, why was it Jupiter? Why, I mean, obviously we know why it's Jupiter, but why was it Jupiter Direct? Everyone, it's always direct. Big bold letters, direct. The direct.
It was from
program.
the original name that I came up with when I did my post on NSF, which was directly shuttle derived.
Yep.
Right.
It also, speaking from kind of a marketing and design standpoint, it's a very motivating word.
Direct.
It's like almost a call to action, right?
Yeah,
We're able
it
to
really
use it on
is.
T-shirts. Be direct.
Yeah. My favorite is there's a picture of gosh, Steve, who's the lunar architecture?
Hubble.
There's a picture of John Hubble pointing at a chalkboard that says direct on
Oh,
okay. That's cool.
You know, I mentioned his name to Buzz Aldrin, and you know, he said our team kind of reminded him a lot about him, right? Because he was the one that got. Remember, you know, the Apollo program also had serious problems. They had to use the Nova based on direct descent, and he was the voice in the wilderness. In fact, I titled another voice in the wilderness for the Space Review article. And that's, by the way, when Paul Sputus, it's tough. I mean, he, you know, John Hubble, I was a NASA contractor at the time, and there's this guy in DC I was working, he was national security advisor for 3 presidents. And he said, Steve, this world can take everything away from you. It can take your job away, it can take your money away, it will even take your life away if you get really bad, right? Your integrity, that you have to give up. And at that point, I knew I just couldn't just sit around and let NASA basically run into a wall. So this was very much a labor of love for us.
Yeah.
For me, it was a little bit earlier than that. I just moved to the States, and the shuttle Columbia had been lost. Well, I live here on the Space Coast in Florida, and some friends actually got me in to the recovery hangar where all the parts were being laid out afterwards. And it was a day when I think it was families and friends who had been invited, and there must have been probably 400 or 500 people in the room at the time. And we were just walking up and down the aisles in between all of the debris, just seeing this and that and all the other bits there. And the place was silent. Absolutely pin drop silent. I've never experienced that before. And I remember this one particular moment, and we were just walking around, and it was at the aft end of the shuttle. And all the pieces had been laid out, and you could see the flap underneath the engines, the body flap underneath the engines. And the chap in front of us turned to his wife, and so quietly, almost nobody could hear it, but I just overheard it. And he said, I hung that on her 6 weeks before she flew. And I have to say that stopped me totally in my tracks. That was one of the most moving things I've ever done in my life. I wish everybody could have experienced what I did that day, because it brought home to me how important this program is. And that's why when I saw such a big problem, and I'm a nobody at that point, but it was, that doesn't make any sense. And then when I started to be approached by people in the program who wanted a voice and didn't have one, it's the least I can do. And it was those two things kind of snowballed together to make this originally for me. And Steve had already been working on his activities before this, and we brought it all together, and yeah, it just grew strength to strength over the years. And it's amazing what a completely grassroots movement accomplished. It really is. I'm amazed at it.
My memory, Ross, is when I first met you, it was the engineering was interesting, but it was all about the workforce down there, because
Yep.
Yeah.
You guys in that area were staring down the barrel of a gun, basically.
And unfortunately, the gun got fired.
Yeah.
You know, Ross, when we were going for the launch, November 16th, I don't know if it was the first time we went there 3 times, but finally see it. But
it's like we were camping there all the time.
I remember in that museum there, the first time I ever saw you get really emotional was going to the exhibit there.
Yeah.
Yeah. I don't know. It does definitely pull on my heartstrings. There's something about it. I moved 4,000 miles to be here. Not many people can say that.
You know, so David, I'm sure you've watched From Earth to the Moon at this point, because I told you at that launch you need to watch that.
Right. I've been watching episodes. I haven't finished it yet. I think I'm
okay.
I'm somewhere in
I'm
somewhere in episode 6
first
right
of all,
now.
It's an awesome series. Everybody absolutely positively.
It really is. It's a great series. I'm loving it so far.
I love it.
I would take that DVD set to Washington whenever I went there, because I just wanted to get into the vibe of the space program before I start talking about it. But the other movie that was in my mind was Lord of the Rings, and there's a scene where it's the first episode where the one of the main characters, basically, if you haven't seen the film, is told that even the smallest person can change the course of the future.
That is a really exemplary quotation of just exactly what first happened with Hobalt and what has now happened with Direct.
And if you also think back to the Future series, right?
Right.
Tiny changes in the past can generate huge changes in the future, but that, we're living today, right? But we can make massive changes in the future if we act at the right point in time and do the right thing.
Exactly. And I would like to switch gears a little bit here into the change that actually occurred. Whoever's got this picture up, that's exactly what I want to talk about. I want to talk about November 16th, which is almost 1 year ago to today. I think we're 5 days away from that. What was November 16th like for you guys? Because first, let's ask the question that I'm sure is everyone has on their minds. Is SLS your rocket? Just modified slightly, of course.
Oh, yeah.
David, I would characterize that. I've worked on many projects in my life, big ones, and they're never the product of one person, 100 people. They're the product of, there's a famous movie you can watch called iPencil, and it talks about how nobody knows how to build a pencil. You think a pencil, really? Wood, lead, whatever else. But when you start drilling down into all the components that go into making a pencil, the chainsaw, do you know how to build a chainsaw too? Do you know how to cut down wood without killing yourself in the process? One thing after the other. You know how to mine metal and refine it. So if we don't collectively know how to build a pencil, we certainly don't know how to collectively build or individually build anything like this. So this took an amazing amount of effort from a tremendous talented group of people to pull off.
Yeah.
You definitely.
And I would also add a bunch of taxpayers paying for it.
Yes, that's my contribution.
Let's not forget that. Yes.
That's my contribution to SLS is the money I give to the government.
Well, and let's think through this too, because Ross, we talked about budget, Ares 5, couldn't be afforded, whatever else. I remember the gentleman that was helping us in the Senate, he stopped me in my tracks, said, "Steve, it has nothing to do with budget. It has to do with what you're doing. The United States, indeed, many countries in the world have plenty of money. We're spending money on, frankly, very worthless things, right? And the ability for the space program to unite mankind has always been there.
Yeah.
Right? Think about it. If we could just divert, 2% of the spending on military. I'm not an anti-military person, but the point is, if we just 2%, we could have colonies on Mars. It wouldn't be just us doing it. It would be everybody, China, you name it.
It's amazing. They've actually done studies out there, and the American public, generally speaking, seems to think NASA's budget is somewhat similar to the military budget.
I know.
Oh, no.
And it's astonishing how different they are.
Well, Ross, that's
One's
a good
like
point.
200 times the other
That's a
side,
good point.
and
Having
NASA's
run
not
a
the winner.
business- Having run a business before, you want your customer to believe you're delivering way more to them than you're paying for, right? So if their perception that NASA is 10% of the federal government's budget, when in fact it's less than 1%, and only half of that, so 0.5% is the manned part, the other half is the unmanned. You know, that's a really stupid program to cut because it's justifying the federal government itself.
Yeah.
In many ways.
NASA punches way above its weight
In
on the
terms
federal
of,
score. Way above its weight.
Real quick, I'd like to get us kind of back on track for a little bit to the SLS. What did you guys think of the SLS launch? What was your thoughts about that?
It was awesome. I thoroughly enjoyed the feeling of the power as it climbed away and the engines pointed straight at us. And you could feel it in your chest and lighting up the sky. It was cool. And to know I had a part to do with that was just icing on the cake.
I really
Chuck,
do. I think this
gap is here for you. We put the gap in there between Steve and I.
Exactly the same
Yeah.
thing.
And
I was
we
supposed to
got
be
the
there.
photo of Chuck the same morning with the same lighting. And I want Philip, being such a fantastic artist, you have to photo retouch him in now.
Yeah.
Yes, please.
Oh
do.
yes,
That would be great.
absolutely. If you, Phil,
David, to answer your question about is this your rocket, for me the answer is both yes and no. Yes, it is, but I like the way Steve put it. At some point, you have to step back and let the adopted parents become the parent. You know, and so NASA took what we did, and they made it their own, and it works.
it
and
works. That's the big thing.
more importantly, they
It
improved
works.
upon it. They improved upon it.
And I'd particularly like to just say, in our team, we had 110 people. We've got 4 here today.
Yeah.
There are another 106 out there. I'm hoping some of them are watching. All right. I just want to say the most enormous thank you to each and every one of you for everything you did to help along the way. I could not be more proud of what we did, and I could not be more thankful for everything we suffered, everything we worked and toiled at, and eventually what we managed to actually do.
Yeah.
That's incredible.
Thank you so much.
It is
Each
incredible.
and every one of you.
It's incredible.
I
how
hope
you guys-
I hope they all see this. I really do.
I'm
I
sure.
haven't had a chance to really say thank you to people before, and I want to.
And this is the
No
perfect
way,
opportunity
no way.
to do it.
No way the 4 of us could have pulled this off.
No way.
What do you mean? You couldn't have just said? You couldn't have just walked up to NASA and said, "Hey NASA, change your design, please," with just the 4 of you? You don't think that would have worked?
No.
I don't think.
No.
I honestly, if it had just been the 4 of us, I think it would have been a situation of roadkill.
We are now at the 3-hour mark, and there is one more thing I'd like to do. Before we, unless there's anything else you guys want to say, before we get to the final thing, because we've been going for about 3 hours, and so is there anything else we'd like to talk about?
Just, I'll ignore the other 400 topics we could have covered.
The last thing I'd like to do is open up Kerbal Space Program and do a Jupiter Direct powered moon landing using Altair and Orion. And we will spend the next couple minutes. I think it'll probably take 40 minutes to do, maybe 30. We can talk about the actual mission architecture that you guys were doing.
Go for it.
You're gonna build it from scratch, David?
Not from scratch. I have
Okay.
mods.
You
I
tried
have
it in real
installed
time?
mods, and I'm going to. East Street Rockets has some incredible Jupiter mods, where he has actually inserted into the game Jupiter Direct core tanks. Yes,
before
I
you
see.
do that,
He's
there's one other thing
texting
I
me
would
right
like to
now.
say
He says, "Yay! I'm so excited." So,
David, can I just get in here for 1 second?
Oh,
There's
yes.
one other thank you I'd like to do before we finish up.
yes.
You and Lewis.
Oh,
your 2 videos
Thank you.
that you did
Yeah.
last year. Thank you so much for doing those. You guys put in a huge amount of work to go in and research what had happened. I think Lewis actually read every thread on NASA spaceflight and read every one of our papers and looked at all of the videos and everything. Crazy person.
Crazy person, Lewis.
I'm seriously impressed with what both of you did, and I know you two kind of did it separately, which is even more impressive. I'm thank you very much indeed for taking the time to go through it, researching it, learning about what happened. It's nice to just have this opportunity just to reminisce about it.
It really is. It's and I'm sure me and Lewis are both honored that you guys have all seen our stuff and thought it was, not terrible. So thank you.
Oh, I thought it was great.
All right.
Let me help with the editing next time.
Sure. Hey, honestly, after that video I just released yesterday, I would love some help with editing because boy, was that not fun.
I haven't had a chance to see that yet.
It's a good companion piece to this video. It's Ares 5 versus SLS,
Yeah.
and so obviously Jupiter is in there as the in a fairly sizable capacity, but it comes in towards the end of the video. And
I was surprised to see the Jupiter in there. It wasn't in the title.
Oh, you watched it? You watched it?
Yes,
Oh,
I did.
Thank you. Yes. I rendered the 246 stretched heavy. I was pretty happy with that. I put that in there.
Hey, it's Steve. I don't know if you know this, but just to pile on, Scott Manley has the Jupiter 3 and the 10 most cursed rockets in history.
But don't worry,
Phil,
it's in good company with Ares 1X.
The Jupiter thing just reminded me of one more thing. Buzz Aldrin told me it's bad luck not to name your rocket, so that's why you started.
Oh yeah.
Yeah. So that's why SLS has like the worst name of any rocket ever.
They call it the
SLS.
Senate Launch System. I actually saw the legislation before it was actually put through to do any corrections. So the fact that there's a lot of engineering stuff in there, guilty as charged. So
All right. So
normally you don't have that much engineering stuff in it.
I'm gonna.
I still think this may have been the worst rocket out there.
I'm gonna slide my stuff out of the way, so that I can
Another
open
special,
up.
another special, I think, from Scott Horowitz.
Mm.
SRB.
I do want to say, just before we wandered too far away, I made my video on the point that I felt that story needed to be told, and I think it felt it needed to be told properly, with the full context and the understanding of what that meant. And then David's video was actually a great compliment because we didn't cross-plan anything, but he went first because I was still scrambling in the editing. And it turned out that we had a very complementary sort of. I was doing the history and the design and all that, and then David did how it wraps up into the Artemis program, which was great.
Yeah,
and
the
it was
two
also
videos complement each other brilliantly. So yeah.
And I also made the video on the Jupiter 3, and Stephen sort of researched there because it was the same thing. I'd never seen anybody take the Jupiter 3 seriously. It was always most cursed rockets, ugliest rockets, stupidest rockets, craziest thing, the biggest rocket, all these things. And I was like, but there's got to be something. There must be a reason. And I got to Jupiter 3 and then I found the original proposal that you put out. And it's like, this makes a lot of sense in the kind of nonsensical way that the you needed that big payload. But yeah, the fact it's two shuttle Cs stuck together opposite each other to cancel out. What a genius design! And I was just that's why this rocket makes sense. And so yeah, that was the sort of reason for that I made my things really.
It came from the fact that I was trying to align with the current shuttle system. So what better way to do that than not to change anything, right, on the existing SRB shuttle external tank, and just add this new component.
Which actually is an interesting question. The Jupiter 2 that you had, that has 5-segment solid rocket boosters, which I find really interesting. Why was that a choice there?
I should just take a second to just point out that the Jupiter 3 and the Jupiter 2 were actually unrelated to Direct. This was Steve's work
Yes.
prior to.
It's still
To get
interesting to
involved in
talk
the whole
about in
Direct effort.
context of Direct.
Yeah.
The Jupiter one from Stephen's proposal is very similar to your first Direct option that you made, and then they sort of join. Then we get Direct version 2. The Jupiter 2 I'm talking about is completely different, sort of future plan really.
Right. So if you look at that core, right, the core can fly independent of the shuttle external tank. So that was kind of the concept there. I mean, again, these are all concepts. They'll never become reality with the politics, budget, and the talent required to make it happen. A lot of talent.
All right, so we're in the VAB. I'm gonna pull up the payload because I did design. Actually, hold on. I designed the whole thing, but I want to do something different. So here's the payload. There's Orion on top, and here's your Altair lander with your extended fairing. So would this have flown as in your design? Would it have flown as one thing, or would you have launched Altair and Orion separately?
We had a couple of different architectures. We got the better performance when we flew the Altair on the other rocket,
All right, so we can launch.
and then but then that scenario did require a propellant transfer.
So,
Right.
how many launches do you think we should do? Do you think we should do 2 or 1 or 2 launches? Okay, 2 launches. So,
Go with this configuration; it'll work, and then you just launch the EDS.
the EDS separately. All
on
right.
its own. Yeah.
Oh, that's right. We had to dock to the EDS. Yep.
Yeah.
Oh, yes. Okay, that's going to be interesting because how am I going to do that? Because the docking ports are right here, and I tested them out last night, and they're specific mods for this game. So they're very difficult. I have to like orientate Orion. It's crazy. I can't just like.
Okay,
test
so
together.
put the Altair on the EDS then.
Okay, Altair EDS, and then we can send Orion up afterwards. And then
Can you do a propellant transfer on the Orion flight?
I'm not sure we can. So how would you have
So,
done
so
it? Would you have?
Ross, we put the
Oh!
EDS. So
Here's what we can do. Here's what we can do if you guys want to do this. We can put a docking adapter underneath here.
There we go.
Here.
No. So what would happen is that Orion and EDS would go up together. Orion would turn around.
No. Orion would go up with an upper stage filled with extra propellant.
Okay. Yeah.
The Altair would fly on the EDS that we were using for the TLI,
Got it. And they would just park. Okay.
and then there would be a propellant transfer from one upper stage to the other upper stage.
Yeah.
Somebody's saying the music is.
So
annoying,
basically,
so I'm gonna
it's
leave it real
propellant
quick
transfer
and,
in orbit. And so when we started doing that, I said, well, heck with that. Why don't we just try to do propellant depot stuff, right? I mean, the concept is you want everything ready to go before you send the crew.
Right. So
That was another thing I made about when you're doing in-orbit assembly, the crew goes last.
is Chuck still here? Where'd he go?
I don't know. No, I think he's dropped off.
And then, based
Hopefully
on the
he'll come back in a
mission,
minute.
the
All right.
mission staging complications in Earth orbit, we quickly moved to lunar.
He's telling me his internet went down. He's having the same problems I had earlier.
Oh. So okay. So I guess let me ask this: if we send up this as one payload, would we then send up another EDS that docks to it, and then that sends it to the moon?
Okay, so you're still thinking Earth orbit. So what we want to do is send an EDS with Altair, get it parked in lunar EML2.
Yeah, that's the other way of doing it.
And then send EDS Orion.
This is
That
a
way-
perfect example
Okay. We
of
can
how
do that.
flexible the Jupiter architecture was. You could do it any of these ways.
Here, I didn't mean to do that. Okay. So you're saying we should put the Altair into lunar orbit and then bring Orion up separately, right?
No, wait. I have to. I'm looking right at the PowerPoint. In this PowerPoint, it states that the EDS goes first, and it goes to LEO. It's got a 15-day max loiter, and then you launch another Jupiter with the EDS, Altair, and Orion. Orion turns around, picks up Altair, and then gets to the EDS that's already in orbit.
And they dock
That's how
to
it.
So that
And then the Altair docks to the EDS. Yeah.
Yes,
Okay,
and then
so
that EDS goes translunar injection.
so then I'm gonna have to
sorry,
make.
that's still very Ares 1, Ares 5. I still like just putting everything where we want it to go in the first place, which isn't to the moon.
So I'm gonna have to do a little bit of a change here. I'm gonna have to put a docking adapter.
But let's see if this works. We could do the EDS
Okay.
Orion, EDS Altair approach.
Oh, also I forgot to do this
EML2.
yesterday. But we need some RCS on the Altair or else we can't rendezvous. So let me just add that real quick. We want to be able to, bring it home eventually. So there we go. That fixes that. So, what's the plan? Are we going to do lunar orbit assembly or Earth orbit assembly?
It's lunar orbit rendezvous.
Or Earth
EML2.
orbit rendezvous? Yes. Which one do we want to do? LRO or ERO?
Well, last time we went to the moon, we did lunar orbit rendezvous.
So is that what we want to go with? We can do
I'll
that.
go for it.
That'll probably be easier because then I
I'm
don't
easy
have.
either way.
Right,
Just EDS Orion, EDS Altair.
all right. So
That way we don't have to dock anything to anything that's not supposed to be docked.
that makes the most sense to me. I'm in on that one. Also, Lewis, could you do me a favor and post a picture of this on Twitter so that I can retweet it and people can see that we're playing KSP, so more people will join. I feel
Welcome
like
back, John.
Yep.
I feel like a lot of people would join if they saw we were doing that. Okay. And I'm not gonna try to go for like an OGIV. I'm just gonna do that. It doesn't have to look good.
Yeah,
Yeah,
that's
it's
fine.
fine.
It doesn't have to look good. It has to work. Okay. So then EDS, there is a tank for that somewhere in here. That's an ICPS. I want the EDS.
Now you want
So,
something bigger.
so then this
Buddy.
this is your EDS, right? We can make it
Yep.
shorter or longer. We can make it really long if we really wanted to. I don't want to do it that long though.
I don't think it needs to be crazy long.
Would you like it to be what color would you like? White or orange?
Does it matter?
It's an
No,
ACES stage, which is actually a NASA developed or NASA paid for project, so may as well go with the white.
White. All right. White. So
Are you using the latest Kerbal?
this is the latest. No, this is not Kerbal Space Program 2. Kerbal Space Program 2 has some issues that Kerbal Space Program 1 doesn't have. So I'm using Kerbal Space Program 1 just so it's the easiest to work with. Okay.
It's a well-oiled older technology, much like Straton-derived technology.
Yes.
How about
Yes. There we go. Now the next question: do you want J2 or RL10? We don't really have a
I'd go
great
RL10.
J2, but we have a sort of J2.
Well, let's do one rocket one way and one rocket the other.
Okay, sounds good. What do we want on this one? What do we want on this one?
What exists?
We have.
Altair's heavier, so I go with the RL10s for the improved efficiency.
All right. Okay. So this is, by the way, this is our J2X analog. It's not very good. It's very big and heavy because I couldn't find a good mod for J2X. Or we could use the actual J2. But if you guys want RL10s, I do think we have those. Let's see where they are.
Have we got the one with the nozzle extension?
I think
Yeah.
I think it's already. I think the nozzle is already extended wherever it is.
That's fine.
Oh, we could do an air startable SSME.
No.
Where is it? Is this it? Oh gosh, that's
looks
really
RL10
small.
size.
That is so
That
small.
it does look like RL10 though.
It is an RL10, but what we need is the boat tail, like in your renders. There we go, and then
Yeah, there you go.
I can.
We had
Just,
6 of
Put,
them.
put at least 4 of them around the bottom, I'd say.
you don't think one would be enough?
No.
Yeah.
A lot
We
of
had
gravity
we had
loss, a lot of
6, right?
gravity loss.
Yeah.
I
A
do.
lot of gravity loss out there.
Is there a way for me to attach multiple engines to this? Why is it only letting me?
You'll
do
probably
one?
have to do a cubic octagonal strut.
Will it feed fuel through that if I do that?
If it only allows one, just do the one.
No, we can't.
Won't get anywhere, Ross.
There's zero chance we would go anywhere with just one RL10. We would be stuck in Leo for a very, very long time.
Then
Hey,
stick the
David.
J2X on the
Here, I'm gonna just do
David.
this.
J2. Something like
David, if I share something real quick, it'll be fine, right? I
Yeah.
just want everybody to look at what we were arguing about earlier.
It may show up
There
on the
you
live
go.
stream. Okay.
Do you
There
guys
you
see
go.
that?
Yeah. So there's the architecture.
Is that right, Steve? That's the lunar. That's the. I mean, that's reusable, but
Well, the advantage of the EML2 is that you can basically use the lunar gravity to basically pop you into there, so you don't actually have to do an insertion burn, which is what you have to do a little bit, but it's not nearly as much fuel being burned as Apollo did.
Yeah, but this looks like the manifesting, right? There's an EDS that takes
Yeah.
LSAM.
Yeah, it's pretty similar, but we're heading straight for lunar orbit as opposed to
Yeah.
EML.
Philip, do you think you could let go of the stream because I was kind of playing through that and
Sorry, I just.
okay, there we go. Okay, this is go up. I didn't need that. Okay.
There
So
you go.
is that looking
Yeah.
okay to you? Let's check what
Yeah.
the.
I think
Yeah.
that's looking pretty good.
I'm gonna move this off to the side a little bit.
Make sure you
But
make
is
sure
it
you
really
save
looking
that
good
because
though?
we're going to use that again. For
It's not
the,
telling us the thrust to
alright.
weight ratio. What are we using? Liquid fuel and oxidizer? No, we need to do LH2 and oxygen, right?
Yep.
LH2 and oxygen. Oh, it probably needs to be liquid fuel then. I don't know.
It
these-
should say in the engine tooltip what fuel it uses.
Oh yes, it should. Okay, what fuel is it using? We can go a little bit bigger there. What fuel is it using? Does it say? I'm not seeing it anywhere.
Part info?
Part info where? Oh,
No. What about in the... Go back to the part menu and mouse over it, and then right mouse. Part.
part menu. Oh yes, that'll work. Liquid hydrogen and oxygen. Oh, is it just liquid hydrogen and oxidizer? Okay, but we just tried that. Let's try just one. Okay, and
Check
then
the fuel flow.
there we go. Okay, so that worked. We have a 0 thrust to weight ratio on the surface.
Yeah.
I'm gonna move you guys back over.
Can
here.
you go back to the 6? Did that not work?
No, I just needed to figure out what the thrust to weight. Okay, so we have a 0.03 thrust to weight ratio, but we do have 4,112 meters per second of delta V. So you can go anywhere so long as you're willing to wait for an eternity. So let's. Oh, there it is. There we go. That's much better. And now we no longer have a delta V calculation.
Just like grab a fuel line and just
That's
drag
what
from the
I'm
tank
going
to
to
the
do
engine.
next. I'm just going to take a fuel tank and I'm just going to do this because
That's 8. There we go.
I'm going to remove everything from it. Bing, bam, boom. There we go. Okay, now we're getting some numbers. So that's a very low TWR. We don't have time for that. I'm sorry. We're going to just do a J2. See, that's the good thing about Kerbal Space Program. You don't have to carry.
There you go.
You don't have to care about efficiency. This thing's going to be able to go to like anywhere. Okay, where is liquid fuel and oxidizer? Okay, there we go. See, look at that, 4,726. That's able to go basically anywhere for a thrust to weight ratio of almost 1. Okay, so then we need an intertank. So I'm gonna just use a payload fairing for simplicity.
Steve, do you think we're going to pass a PDR on this?
Yeah, sure. It'll pass if you don't like look at anything I'm doing here. Just ignore it all. So here's our interstage. It's not going to look great, but it just needs
That's
to work.
fine.
Fairing expansion, fairing staged, and auto strut. Okay, so now, so this goes here. So then after that fairing goes, then that goes, that goes, that goes, and that goes. Okay, good. So the next question is, do you guys prefer the stretched heavy or the four segments?
Yeah, put your money where your mouth is, guys.
Because we can.
I prefer the 4 segment, but this is a show partly about SLS, so let's go for it.
Well, it's about whatever you guys want. Because let me tell you the truth here. This is not a physics game. This is a fun game. So no matter what we do, this whole stack is getting into orbit. It's with most of its fuel.
With most of you. Go for the stretched. Why not?
You want to do stretched?
Let's
Okay.
go for broke. Why not?
Okay. Oh, that's not correct. That's not correct either. Which one is it? Okay, that's too short. That's too short. That's too short. And that's got okay. There
That
we go.
looks about right.
That's
That
that's the SLS style. Okay.
Yeah.
Now first of all, we need to change that to liquid hydrogen and oxygen. Okay. So now auto strutting that. Now, coupling. We need to attach some boosters, right? It's booster time.
12 at least.
12. You want to do hey, we could probably build Jupiter 3 in here, but I don't want to. We don't have enough time for that. Okay.
I have built Jupiter 3 in KSP. It's
How
it's a
is
big
it?
boy. It's a big boy.
Does it get out the door?
You can build it.
That's a delight.
Any
A delight
rocket
in
you build
KSP.
can get out of the door in KSP. That's the fun part. It doesn't
I
matter.
actually had to download a mod that made the VAB walls invisible, so I could actually zoom out far enough to see it all.
Okay, here's our 5-segment boosters.
They might be a little high.
Yeah, they might be. Yeah, that's that
There might be plume impingement there.
Yeah, there might be just a little bit. Okay, look, we gotta make this rocket go even taller. Okay, so that's that, and then of course we want to have the forward skirt, which I'm going to have to build. 1, 2, 3. There's our forward skirt, and it doesn't match. Why doesn't? Ugh. I wonder. You know what? I bet you there's a forward skirt somewhere in here. Yeah, there it is.
There we go.
I also need to rotate these because these are not in the correct orientation. They need to be sideways. Yeah, there might be a little bit.
Turn them out a bit. Yeah. There you go.
Oh.
That'll do.
And I need to turn these around. Oops. There we go. All good. And then finally we can do some aerodynamics. Is it correct? Nope, that's not correct.
Yeah, you just saw it.
Yeah, I'm just gonna use the one this isn't the right size either. I'm just gonna use the fuel tank. That works. And just drain. Oh no, it doesn't work. Okay. So maybe it is.
It's
There
right
was
there.
a nose. I saw a nose down the bottom somewhere, I thought.
That's too small.
They're right there.
Where? Right here?
Yeah, isn't that?
That's way too
No.
big.
Down a bit further down. Maybe those ones.
One of.
I did see it earlier.
Yeah, I thought I saw it too.
I saw the correct one with the holes on the side, as it were.
Oh, with the holes on the side. Oh, though. Okay, maybe that's
Yeah,
a
yeah.
little.
Separator
Yeah, the
motors.
4 little.
Let's see. Okay, so
I
then
can't remember what they are.
The pushers.
is it this thing? No.
No, that's the skirt.
Oh, that's it. Oh, this will be the engine section for NL. Well, it says for NLS, but you know that's basically the
Yeah,
same thing.
close enough.
Close enough. Ah,
Close
is it
enough
one
for
of these?
government work. Yep. Unless you want the boat tail, unless you want the actual direct boat tail.
Well, I don't think the actual direct boat tail is in this version of the mod. I didn't update it like I should have.
Is
I thought I saw it, dude.
Yeah, that looks like. No, that's only 2. All right,
Yeah.
never mind.
Yeah, I don't think it's in here.
No.
This is going to be a problem if we don't have booster things. Okay, you know what? I'm not going to waste time. I'm just going to build one. Watch this. Watch how fast I can do this. Just got to build it with fairings sometimes. There we go. Okay, that's all that we need for that. It looks correct, and that's all I care about.
That'll do.
Oh, why is this? Okay, hold on. I've made a mistake here.
Downside of not doing
See,
the
okay.
engineering properly.
This is a bit weird. Why is it not doing this correctly for me?
Oh, you've not. It's mirror, not radial symmetry.
Right. Oh, yes. Okay. Thank you.
It kind of frightens me because there's a whole generation of kids out there who now think this is how easy it is to do this.
Honestly, it is a bit bad. It is honestly a bit bad. People think that you can just build rockets like in Kerbal Space Program, when that is very clearly not the case. You can't just Lego turn rockets into, pieces and put them together. And what's worse is that SLS kind of enforces that because they just put a Delta IV heavy stage on top of a space shuttle tank, which no, that's not what they did. But
Yeah,
okay.
they should introduce a government and contractor mode where you try to do things and then you can't get them.
all right,
Like a Sim NIMBY, but
here's the SLS
Alright.
engine section, but I don't think we
That'll
want
do.
it. I think we want the NLS one.
Yeah, isn't that? Oh,
Where'd the NLS one go? I saw it a second ago. Oh, it's up here. Boom. There we go. Oh wait, hold on a second. I need this piece, because then we can close off that LOX line. That's a bit too tall, so we're just going to do a. Actually, you know what we can do? We can sort of do the actual direct engine section. Sort of. It's not going to be perfect, but it will look sort of correct, and that's the game we're going for here. Is sort of
That'll do.
correct for direct. Okay,
There you go. That'll do.
That'll work.
that looks somewhat correct. Let's move it up.
someone in
some-
chat says there is a part for it.
Who's saying that for the engine section for direct? Because I'm not seeing
Yeah.
it. Okay, I'm going to give us some plates down here at the bottom.
That's to stop the base heating.
Yes, it is to stop that base heating. You're exactly right. But it's also to give us a place to attach some RS-25 engines. Or we could use... Actually, no, there is no RS-68 analog. Never mind, ignore that, sorry. There's no RS-68 analog in this game, which is kind of sad, because RS-68 is a pretty cool engine. Alright, that looks bad.
That's all right, David. Don't worry about it.
Okay. There we go.
That
There we
looked
go. Oh, you gotta be... Okay, now, we can finally finish this. Put the RS-25s in. They're a bit clipped right now.
Those look cool. Doubled up engines like that. That was good.
Space saving.
It's a bit longer than you guys had it. Yeah, those are overlapping. We're going to use the KSP versions, which should be just...
Yeah, that size doesn't look right either.
Yeah, it was a bit... I think that was a little bit off. We're just going to use these.
I like the idea of having them facing other directions.
Just for stability purposes, of course. Have them face... There we go. Now we've got 4 in
One over
line.
here, one over there.
Yeah, just plop some RS-25s down. They don't cost like, what, 100 and some odd million?
I have to say,
Extra
health
gimbal.
and safety has something to say about all these people walking underneath.
Nah, they're
We
fine.
haven't even seen one of the fuel trucks does like a drift spin underneath occasionally.
Oh yeah, it does.
So-
Oh, I wish we could show that.
Yeah.
Okay, so everything should be auto strut and ready to go. I'm not gonna waste time putting Separatrons in those boosters. I'm just gonna hope they don't blow up our rocket. So save that. Oh, I hope I saved it as the right thing. I need launch clamps,
Structural. Yeah.
so we don't fall over on the launch pad. That would be pretty not cool. And so those go there. There we go. All right.
Light that candle.
Let's light this candle if it works. There's like a 75% chance this thing works, and a 25% chance this thing blows up spectacularly because I forgot to auto strut something. Either way, as Elon
Well,
Musk says, excitement
As long as you
guaranteed.
fitted large enough explosives to take it out, then you'll be fine.
You didn't put an FTS on there, did you?
No, the rocket is the FTS system. Okay. Oh, these are supposed to be here. Okay, good thing we didn't do that. Okay, can we get a countdown? Wait, hold on. Let's check the staging. So the engines go, then the boosters go, and it separates. Then the boosters separate. Then the J2 separates. Paley fairing goes. Okay, we can get this thing to the moon. Can we get a countdown? Are we ready?
5, 4, 3,
2,
3.5.
1, ignition, and liftoff. There it goes. So what is this? This is the 241 stretched heavy, right?
Yeah.
Yeah.
And you know, we'll say it's stretched just because we need to get Altair to the moon, right? We can use a smaller version for just sending Orion.
How do you know where it's going?
Because I've played. I can. It's hard to explain. I just see those numbers and turn the rocket at 2,000. Uh-oh, did we lose something? Oh, yeah.
You didn't put struts at the bottom.
Yeah, yep, there goes the rocket. Why did we? What happened?
I think we've got
You didn't have-
No, we can save this. Watch this. There we go. Okay, we can save this. We've got. Look at all that Delta V. We can do this. Goodbye, goodbye, Direct. You were.
pretty standard design afternoon, really, in the Direct office.
Oh my god. I was not. I have to say, that was not what I was expecting. But you know what?
Apparently,
No!
you're
Oh, it's
defining
going.
I have missed something.
It's going. Okay, you know what? We're gonna try to.
No,
land
we're
it.
going the other way.
We're gonna land it now.
Are we at the moon yet?
No, not yet. Not yet.
Oh.
You know, though, if there had been crew, if the crew had been in the airlock, they would have survived. Okay. Well, that went. I don't know if I can say it went well. Revert. Oh.
Apparently we're in Elon world here, not afraid to fail.
See, this, if Jupiter had just done what Elon Musk does, it'd be perfect. Okay, why was that not working?
You didn't have connection points.
You know what it
at the
is?
bottom.
You know what? Yes, that is true, but
Yeah,
there's also no
connection
way to
points.
get fuel from there to there. Uh-oh, didn't mean to click that button. So hold on, real quickly. I have to go inside the rocket and add a fuel line, because apparently there is no connection point from this tank to this tank. There we go. So this is using liquid fuel and oxidizer, and these are using liquid fuel and oxidizer. Okay, and then we need some struts. Connecting these to there. Bing bang. All right, there we go. Now it shouldn't blow up. Which is the goal of every rocket, right? It shouldn't blow up this time.
Famous last words.
Famous last words right before this upcoming launch. That will definitely work. I'm sure of it.
That was Starship Orbital Flight Test 1.
Oh, yes. It was, wasn't it? I did
Yeah.
say it was going to be 100% successful, and, well, I can't say it was. I can't say it was. Okay. T0. Let's get these up to here. Okay. That doesn't look correct.
Oh, goodness.
I am. Well, you know what? We're still going in a direction.
The process of playing KSP is very iterative.
Yeah, I don't think this is working. I don't know why it's not working. Let's try to land me out there. What? Okay. I don't know. This wasn't supposed to happen. It was supposed to work, and we were supposed to actually do the mission, and it was supposed to be really cool. But as you can see, that
It's still very cool.
it is interesting.
David, this reminds me of the question we asked. What's an airplane?
What is an airplane, Steven?
It's what holds the engines back.
Yes. And this engine has nothing holding it back. It is just,
It's on its way. Hey, maybe Ares 1 would work.
maybe if the goal was to, go through the atmosphere at hypersonic speeds very fast, and it didn't have astronauts on top, we might hit escape velocity with this SRB. It might happen. Look at how much fuel's left. It isn't going to tell me the Delta V, but let's take a... Yeah, this thing's leaving. This thing's going by. Well, we've made it past the moon, and we've made it in. We are now in orbit around the sun with just an SRB.
Yeah. One small detail: no lander, no astronaut. So
yeah, no, just a small thing. This is what Ares 1 truly was meant to be. Look at all that freaking 5,000 meters per second. How is this even happening?
Still burning the fuel.
It's still going. Oh my gosh.
Direct treachery to Mercury.
It actually is below the orbit of Mercury, or MOHO. There it goes. It's finally stopped, and we are well above the planet and leaving it fast. Okay. I'm going to try this one more time. At that point, I think maybe it works better in reality than in practice, in game.
no, Dave. We could have a second video, right?
Yeah.
Once you get this figured out.
Perhaps. I'm gonna replace these SRBs with some better ones.
This is what would have happened if it had just been the direct team of the four of us.
Yeah.
We needed
Without
the
all
other
the NASA
106
help, yeah.
to get it to actually go places.
Yeah.
Yeah. Well, I mean, we went to like Mercury just now, so progress.
We did do that.
That was a fast transit time.
That was a fast transit time. Okay, these SRBs are the stock SRBs of the game. So
Are they
work.
strapped?
What?
Do you have them strapped on?
I'm about to strap them on right now. These are the 4-segment variants, so we're just going to use a 4-segment Jupiter. Okay, there we go. That should hold them in
Strap
place.
them top and bottom.
Yes, we have to shorten the rocket first a little bit though. No. Is that looks correct? Roughly. There we go.
Yeah, that's about right. It's not far off. It'll do.
It'll do. It'll work. I'm really hoping it works this time though. I really am, because I want to see this thing go.
It's good enough for government work.
Yes, the government would love this rocket. In fact, they love it so much they actually built it. It's called SLS.
Yeah, the lowest cost bidder, right?
Yep. How does it feel to sit on a
He
rocket
went
paid
there.
for by the
He
lowest
went
bidder?
there.
Oh, that's going to be a problem. I gotta fix that too. Do you guys have any fuel line problems indirect, like I'm having right now?
Yeah, I worked on those for quite a while, actually.
All right.
Yeah, getting the imagery right, the public imagery right, was quite good fun actually.
Did
All
you
right,
use a
here we go.
17-inch fuel line or a 22?
SLS uses 17. I didn't even know that you guys were using 22 until last night when we did the test.
Yeah, we decided to go up to the single larger diameter to be able to feed all 4 engines instead of just 3 on the shuttle.
So that answers the
Whereas
question.
SLS went with dual pipes, one either side, and you can go either way.
Yeah, I agree.
That does answer the question, because I had that one for a while. Like, why did you only guys use? Why does SLS need 2 of them? And that answers it.
Again, we wanted to be shuttle derived. We wanted to be as close to the shuttle system as possible.
Okay. I think.
But SLS didn't have that problem. Shuttle was not.
All right.
Well,
I think.
there was also an issue that the arms on our tower could only approach from one side, so we wanted all of that equipment on one side, so that it was all accessible from the swing arms out to the pad.
I
It's
see what the
amazing,
problem is.
Ross. I look at airplanes I've worked on and designed and stuff like that. There's not a feature on them that wasn't something. There's a reason for it, right?
Ah, hey, this cheat mode, it explains ESAS.
Does it really? Also, I'm using the cheat mode because I figured out the problem. The fuel of these engines are coming from this tank, but not this tank. So I'm just going to ignore that and just get us to orbit anyways.
Your solids aren't going to burn out. No,
That's basically what. Yeah, you're right. That is what he says with them. He's like, oh, we can ignore that. It doesn't matter.
I was looking through the Robotle document. It's 116 pages, and there are dozens and dozens and dozens of points in their document that it took us a year to write the rebuttal because there were so many points. It's
I think it's a
crazy.
year. We did it in a couple months, didn't we?
When we got around to it in the end, yeah, but I started it like 8 months before we really put a concerted effort into it. Even then, I mean, it was still like 3 or 4 months of actual work on it. And I remember we had other presentations and stuff in the way as well.
Yeah.
Right,
It was a challenge.
Things are getting quite hot. I hope they don't blow up.
I actually think the rebuttal document took longer to write than the AIAA paper.
Oh shoot.
Yeah, something's getting really hot there.
Yeah, I just realized.
That was
That's not good.
That did not work.
Go on, land that. Go on.
You know what? I realized my
Well, it's going to land
mistake.
somewhere, but it's going to be on the earth.
My mistake is that I didn't adequately think about the fact that if I turned on infinite propellant, the solid rocket boosters would have infinite propellant as well. So and also I don't know. I don't think this is going to work. It was a valiant effort. We got the showcase.
I'll tell you what. Have another go offline and add it as an extra video as a link underneath.
Wait, I'm sorry. What did you say?
You need to
Do
break
it
this video
offline
up.
and add a video link to it later.
Yes, I will do
Right.
a recreation of Jupiter.
David, this could be the blooper segment of this whole video.
Yes,
series, right?
the one where we try to get to orbit using the Altair lander, right? Do you think Mike Griffin would have? Approved this as the launch vehicle?
No.
I think he would have loved the video, though.
Okay, I think I think the gravity is now fighting our engine. So
Yeah.
He's hovering.
so let's
I don't
stage.
think we're hovering. I think we're falling like a brick.
Hey,
No, we're not falling. We're flying with style.
yes. We staged. We lost our engine though, but we still have propulsion. Watch this. We still have propulsion on the Altair. We can do a landing. We can do a landing. Hold
This
on.
feels like the final few days of the Constellation program.
Here, we can do it. We can land this thing. Look, our speed is going down ever so slowly. Will it hit zero
a couple
before?
of extra engines on it and some giant fairings, we'll be fine.
I remember
What
when
do you mean the engines
Constellation
aren't
was
powerful
on
enough to
airport,
lift
it felt like just watching it slowly die.
Let's see. Is this thing gonna hit zero before it hits the water? That's the question. And I doubt that answer is yes.
A lot of blue down there.
There's a lot of blue down there.
And it's not sky.
Is that the second stage? Yep, that's the second stage. Oh no, that's one of the SRB nose cones.
Oh,
All right. All right. Goodbye, Altair. And with that, I don't think we'll be trying that again. It's clear that it did not want to work. I would like to first off thank E Street Rockets for the Oranges mod. It was really great, and I was happy to use Jupiter Direct for the video. If you want to download that mod, I'm sure we could put a link to that in the description somewhere. But with that, I think this is the end of the stream. Is there any final words we'd like to? From everybody?
I have one question.
What's your question?
I promised someone that I would ask this question. I'm going to need to screen share real quick.
All right, go right ahead. I'm done with KSP for now.
What's up with this?
Oh,
crikey.
yeah. What is it? What on earth is that? And it says Direct Part 2.
Afterwards,
Yeah.
we looked
Yeah.
at
yeah.
Afterwards, we looked at a commercial launch operation. Take the team that we had and start turning it into something else.
Goodness gracious, that thing is huge.
Yes, it is. Yes, it is.
Yeah.
This was 140 metric tons to low Earth orbit.
On it,
Yeah.
on it.
It's kind of an interpretation of like a Sea Dragon come Starship.
And
Yeah.
it was reusable.
And that was the intent. Unfortunately, internal politics killed that one off.
What kind of internal politics killed that?
I don't really want to be disparaging in any way, but I have a feeling members of the team suddenly started to see dollars in their eyes.
Oh.
And it kind of went a bit pear-shaped at that point.
Do you think this could have, if everything had went well, do you think this could have ended up flying?
Oh
With the
yeah,
right funding behind it, sure.
Where do you even launch this thing from? The ocean?
yeah. The
We
ocean.
looked at the ocean initially, but it was actually quite difficult with the power that we were using. We were risking marine wildlife, and that was a problem that we thought we could overcome, but it would have been one heck of a challenge.
So instead of fishes floating on the ocean, you have whales floating on the ocean.
Okay.
But this gets rid of the stage 0 problem that Starship's dealing with, right? Because
It launched out of the water and landed back in the water, just like Sea Dragon was intended to.
right.
The ultimate problem with this was it didn't really have a beyond LEO capability.
Right. Okay.
But this was part of an architecture where a propellant depot was waiting in orbit,
Right.
and there was a tug system that could take you up.
Right, Ross. When I
Yeah.
was looking at the business model for this, I'm thinking we can
Exactly.
put so much freaking mass in orbit. Nobody's going to be able to afford that many spacecraft. That much, because spacecraft are expensive too.
Yeah.
Though, but another shout out to SpaceX. The upper stage of people don't talk enough about the upper stage of the Falcon, the production rate they're getting out of that sucker because they throw them away, right?
Yeah.
And also the production rate out of Starlink. Those are both, having worked in commercial production, those are both massive improvements over how the industry used to work. Anyway, off my SpaceX soapbox.
Oh, I see
Yeah.
Artemis in there too. Artemis crew transport ship.
Well, we called it Artemis before
Oh,
NASA took the name.
gotcha. I gotcha. It's a very
That
popular name.
was 64 people on one ship.
All right, so I've got one final question. So you started with Direct, then you went on to this. Are there any other projects that you guys are going to be pursuing in the future, potentially?
I don't think so, although we are keeping an eye on what happens, and you never know.
So I'll answer that, David. After this, after we said, hey, NASA, you're going to take it, and they did a great job with Artemis, I started working on a new form of nuclear power. It came out of Kirk Sorensen, who I met. I talked to him on the phone one time. Dr. Farquhar said, hey, you got to talk to this guy, Kirk Sorensen. He was leaving Marshall because he wanted to get into a new form of nuclear. It's not really new. It's already been done, but it's molten salt reactors.
Oh yes. I watched a documentary about molten salt reactors once. It was pretty good.
Molten salt, yeah. So I'm working on the chloride fast reactor right now, which basically runs off of spent nuclear fuel. So that's my hobby. A lot of guys watch sports and stuff, but my hobby is this kind of stuff. In many ways, Direct was a hobby as well. But I think, providing, if you look at civilization in general, our civilization doesn't work without cheap, abundant energy.
Right.
So we have to make that transition. At one point, Ross and I were trying to hook up with Elon. Said, look, we're not going to have a Mars colony if the Earth colony fails, right? So, at least in the near term. So, anyway, that's kind of what I'm working on right now, just behind the scenes.
They're a game changer. They're a game changer, like a lot of the other stuff Elon works on, and I'm surprised he hasn't gotten into it.
Well, the reason why Kirk Sorensen came up with it because it's the only way to power the lunar base.
Yeah.
I mean, you can use the radiothermal generators that we use for the space probes, but to get some serious,
if you want a large base, it's not practical.
Exactly. For a large base, you're going to need it. And
especially in civilization with cities.
It's a perfect
and it's only a matter of time before we're going to have to do mass salt desalinization.
Exactly, water
here on Earth, and these are technologies. You want electric vehicles, you've got to provide the power.
Right. So these are the kind of things, and this is where space is so relevant to the Earth, is that by trying to do hard things in space, it forces us to develop things that work in space, but also will work on Earth. And that's why no one should look at the space program as a waste of money. It pushes people to do things, that are hard. Right? Yeah. Like Kennedy said, we're doing it because it's hard, not because it's easy. So.
And I'm also going to give a gratuitous plug to a new project that I am involved in. We haven't announced yet. That's probably coming in January or February, but it's a new charity that's going to be flying student experiments in space.
Oh, very cool.
We've also got a space camp type operation, a camp here at Kennedy Space Center planned for next summer for kids. And we're going to be doing model rocket competitions around the country and drone competition, drone racing, and you know, a bit of this and a bit of that. We've got a lot of interesting and fun activities for students and educators.
Ooh, can I bring my 1/48 scale Saturn V?
Yeah, yes.
Oh my goodness,
Yes.
148?
You must bring it, in fact.
It's required. You can't come if it isn't with you.
It's 8 feet tall.
8 feet.
We'll be announcing that in the non too distant future, so I may ask for another one of these programs.
You know what? Be my guest.
Ross,
If we can make
so
it work,
Ross-
it'll happen.
Ross, what you're talking about is also critical because to put that fire in people,
Yeah.
to go into engineering, to go into technology, to get through the math, do all that kind of stuff. I remember I was terrible at math, believe it or not, until I found a use for it.
Yeah.
At which point I would tolerate it enough to get through engineering school, right?
Well, the other thing is to get the students when they're young.
Yes.
There's a lot of kids out there who, for one reason or another, bypass things like aerospace because they think it's hard or they can't get into it or there aren't any resources for them to make any kind of contact into that world. And that's one of the big things that we want to change. We want to provide the course materials. We want to provide resources for the educators to be able to bring it to them because they don't know how to teach aerospace subjects. So if we can provide all of that on the back end and the courses and everything else, then it just opens it up for everybody.
Indeed it does. Indeed it does.
So watch this space on that one.
Watch this. Yes, yes.
All right, everybody want to see the lunacy that I'm spending my time on?
Oh yes, let's
Yes.
see. Let's
Oh
see.
yeah.
If this is what I think it is, it's brilliant.
Since nobody seems to think that Starship needs landing legs,
Oh yes. Oh my goodness gracious, that is incredible.
Lunar landing
wow.
legs, the Starship.
Oh,
I
and
think
it's the Martian
absolutely
surface
brilliant.
too. Oh my gosh, that is incredible.
yeah, and I'm such a lunatic about it that since there's so many naysayers now, I have to teach myself NX so that I can actually do a stress analysis of the design because all the haters out there. Anyway,
This is incredible. Honestly.
Yeah.
And,
I think Philip's come up with a fantastic idea. It's what we were talking about earlier with the lunar regolith debris issue.
Mm. Don't they
And,
intercept
you know, it's
also?
how are you going to land a Starship on the moon if you're accelerating particles from one engine that might hit the next engine belt?
it's actually
I thought
Ross.
they put the engines on the top stage though. So
They
that
did
they're
for
not-
lunar,
Yeah.
but Steve,
Yeah.
that is actually
But Mars
Ross.
Mars is basically the same issue.
In a conversation with Ross, there's even a bigger issue that I hadn't thought of.
What?
If you have to abort to orbit, let's say Starship has to abort to orbit, it's not going anywhere. It's got to come back to Earth. It's got astronauts on it. They got to land it.
well,
What?
they can send up
they
Dragon.
can't abort back to lunar orbit and get in Orion and come back.
No. What if you lose too many engines just after staging,
Got it.
and you're going to land in the ocean or you're going to land in Europe?
Yeah, you have to
Oh.
be able to
How do
land.
you land a Starship if you ain't got legs?
Yes, that's a good
Especially
point.
considering
You-
the flip,
you don't have
flip and
to land
burn
it,
is a
though.
part of the requirement.
You
not only considering there's no escape system, right? So
Yes.
the escape, you have to escape the Earth basically.
It's going to be like the Falcon 9. The Falcon 9 flight with the Dragon on it, where the
Yeah.
rocket exploded, the upper stage blew up, and the Dragon came off the top perfectly intact and made it all the way down to the waterline, and then it collapsed. If they had just put in one line of code, activate parachutes if you're falling.
Yeah.
All right, they'd have recovered that Dragon capsule. This is basically the same sort of thing. If it happens and they didn't look at it, everyone's going to go, "What a bunch of idiots!"
Right.
Yeah.
Yes.
Yeah.
Although I have to say they could
Especially if they kill
probably,
people.
if the crew's stranded in orbit, they can probably just get a Dragon up there pretty quickly and get him back, right?
Yeah,
And
you're
in
never
orbit,
late. You're
fine,
just
but
early
that
for the
can
next
only
one.
happen in like the last 10% of the flight. once you've gotten sufficient delta V to get to orbit.
That's true. That's true.
What if
But
you
the
don't
entire
have
second
sufficient delta
stage
V to get to
flight-
orbit?
The entire second stage flight, there's probably 80% of it where if something goes wrong,
Mhm.
what are you going to do about it?
All right.
And first stage flight, for that matter.
So real quick, we've got 10 minutes here until we've been streaming for 4 hours. So for these last 10 minutes, I would like to see if there's any audience questions that we can answer before we go. So if you've got your
I'll-
questions, put them in the chat and we'll relay them to the experts.
Nothing new on the NSF thing.
Oh, yes, Michael.
Not related to
okay,
that anyway.
Okay, Michael has a question for any of you. If you're he's going to soon have a 3D model of a Jupiter rocket, and he's wondering if any of you would be able to sign it for him.
Where is he?
Yeah.
You'd have to I don't know. He wants me to ask you that.
Next time he comes to the Space Coast and catches a launch round here, I'm more than happy to.
Well, he says he's in Florida, so maybe
Okay.
maybe he could. It's a possibility.
So Ross, while we're on that subject, is there a chance we're going to get VIP tickets for Artemis 2?
I'm working it.
All right. I want to bring my wife. I want to bring
Thursday.
my wife this time because she deserves it. She was
Yes.
home with 5 kids when I was
Actually, that's
doing
what-
all this
yeah.
crazy stuff.
Yeah.
And
Yeah.
hopefully this time I won't be sick.
Yes.
It would really be nice to see you down here again. And also I'm hoping maybe we can arrange something for the first Starship out of here.
Oh,
That should be when are they planning to launch Starship from Florida?
How long is a piece of string?
well, once they figure out how to launch it from Texas without throwing concrete through the air.
I think they'll get 3 or 4 flights out of Texas.
That's
before
going to
it-
happen on Friday, Steve. Come on.
Yes,
Oh, that's the-
100% successful. It will go right. Everything will go right.
Did the salamander sign off on that, or
All right.
Poor Philip keeps having to put back his flight tickets and his hotel rooms every
Yeah.
time the date changes. I get
Steve,
a string of text messages from him, and he's like,
Steve, Elon was joking on Lex Friedman's podcast that he didn't realize he needed a fish license, so he just had to go down and get a fish license.
yeah. Well, you can't go to the moon without getting the fish approval, apparently. So.
All right.
Right.
Any other questions, David, or can we?
The only one I got was apparently somebody who missed the Leviathan asking if you tried to resurrect Sea Dragon, which of course, yes, you did
Yes,
try
and
to
in actual
resurrect
fact, I
Sea
was in
Dragon.
contact with Bob Truax before he passed away on that project as well. And he was the originator of the Sea Dragon concept.
Oh, really?
And he was very supportive of that. He thought it was a great idea. The big thing that we'd actually figured out with that one is the steel that they were using for the Sea Dragon would not actually have worked.
Really?
The heating environment combined with the hydrogen embrittlement of the hydrogen on board
Right.
was a killer for it. It made it brittle, and it would have collapsed like some aircraft, marine aircraft landing gear.
But Ross, what about a methane LOX approach so we get rid of the hydrogen?
Well, actually, we ended up finding another material. We actually found it, and we got it, and it was one that would actually have worked. And that was our unique contribution to the concept, and it made the whole concept actually gel.
That's pretty cool. All right, though.
So yeah,
I think this is we have come to the end of this 4-hour long stream. I want to thank everyone, Stephen, Ross, Philip, and Chuck, and Lewis too. Thank you guys for joining me. This was incredibly fun. Oh wait, of course, as I start doing this, we have a question. So let's just get this. Okay.
let me just say
they
thank
wanna
you
know-
to David and Lewis actually as well.
They want to know
We
what your
really
opinion
appreciate
on the Raptor engine is. What do you guys think about the Raptor engine? They just want to know your opinion on the Raptor engine.
What a piece of work. I think it's fantastic development. Once they get it reliable, and it sounds like the later models are already well on the way to that, I think that is going to be an absolutely stunning engine.
Indeed.
I have to. Go ahead, Chuck.
I was going to say it's going to be the standard bearer.
I have to say though, after seeing IFT-1 with 33 Raptors going off, or at least 31 when they lifted off, it even, well, from 5 miles away, it still did not compare to the SRBs.
Yeah, that's a good point. The SRBs are just monsters. They are
The SRBs just feel like you're watching something incredibly dangerous and unnatural.
Yeah.
It really is.
Yeah, there's a point in that launch where you're thinking, should I even be this close to this damn
Yes.
thing? This is like crazy.
Well, they said that to us several times on the PA.
Oh yeah, yeah.
If anything happens, go to the Saturn V building.
Yeah.
Oh yeah, like
The
that's
toxic
what protects
fumes.
it from flying debris.
If the newest
Yeah.
giant bomb explodes, go hide underneath the old giant bomb. All right, I do think that is where we're going to end it. Thank you all for joining. I hope this was as fun for you as it was for me, because I had a whole lot of fun listening to this stream. So, thank you for your
Thanks for
contribution
joining.
to the history of spaceflight.
Thanks, Lewis. Thanks, David.
Thanks, Lewis. Thanks, David.
And
Great
Well,
to
fun.
great to catch up with the rest of the gang again.
and
Yeah, thanks
Fans
everybody.
back
It's really
together.
good to see you guys.
good to see you guys as well. And everybody who watched, thank you for watching. We had a pretty
Especially if you stuck with us.
We had a pretty consistent view count throughout the entire video. I didn't think it was going to stay like that. We had like 30 people the entire time watching us. So that was great. That was incredible. So thank you, viewers. Thank you, engineers. And thank you, everybody. This has been incredibly fun.
And go SLS.
Go SLS. And, of course,
Guess
Go Artemis.
go SLS, go Artemis, go Orion. And for the upcoming launch, go Starship. 100% successful.
Especially
Yeah.
for Philip,
Yeah.
go Starship.
Yep.
All right.
Go enjoy yourself, Philip.
Yeah.
I will.
I think that is where I'm going to end
Take
the stream.
pictures.
Oh, well.
All right.